Okay. Good morning to everybody who's joined us physically and online via our virtual link. It is an honor to welcome you to today's seminar, and it's great to see the diversity of skills and technical leadership, management, financial leadership in the group today. So my name is Devaksha Maraj. I am the chair of the SAIEE Energy Storage chapter. It's my honor to open up this important seminar to discuss lessons learnt from the recently installed grid-scale Hicks battery energy storage system based in the Western Cape. So to start off this morning, I am going to introduce one of the representatives from the University of Pretoria, Marcia Indala, who will get us through the safety brief for the morning. Who's still outside?
Morning, everyone. My name is Marcia. Welcome to University of Pretoria, especially welcome to the Department EECE. On behalf of Prof. Naidu, I welcome you. For safety precautions, first thing first, we have these two alarm systems. One is for fire and one alerts the security services in case of any emergencies. For fire exit, if there is any fire, the exit door to the parking area is our assembling for fire and bomb issues, but then there shouldn't be any today. Please get this number in case of any emergencies. Is our security emergency number 012-420-2310. Thank you. And then for the bathrooms, we do have bathrooms just outside the reception.
Today is an opportunity to share knowledge, ask questions, and build on the collective experience as we look ahead to more transformative energy initiatives. I encourage each of you to engage fully in the discussions, share your perspectives, and take away new ideas so that we can inspire further progress. Before we dive into the discussions, I'd like to cover a few of my own housekeeping rules to ensure that the seminar runs smoothly. Please keep your mobile phones on silent. If you do need to take a call, kindly excuse yourself and take the call on the outside of the building. We ask that questions be held until the Q&A session to ensure that we stay on track with our full packed agenda. Marcia has gone through the restrooms and the location and the emergency exits. Lastly, for those who are joining virtually, please use the chat functions, which will be monitored to submit any questions or comments, and we will try to address them during the relevant sessions. I officially opened the event and want to once again extend my warmest welcome to all of you. I look forward to the valuable insights that will emerge from the conversations today. To start off, I take the opportunity to introduce you to my colleague, Teboho Machaba, who will be introducing our speakers for the course of the day. Teboho is an EXA registered professional engineer who holds a BSc Electrical Engineering degree as well as an MSc Electrical Engineering degree from the University of Witwatersrand. He is currently working as a chief engineer in the NTCSA System Operator Operations Planning in the Specialized Studies section with particular focus on the Wide Area Monitoring System, which utilizes phaser measurement units. He's a senior member of the SAIEE and the past chairperson of the SAIE's Gauteng Center, who have won the Center of the Year Award in 2019. Teboho.
Good morning, ladies and gentlemen. It's an absolute honor and a privilege to be here with you today. I've been on the receiving end of a tender to at least introduce speakers for this seminar this morning. So it's an honor once again. And thank you for being here and making time to be here to share knowledge and information on this wonderful topic. I think all of us are aware of the two-pot system that's going around. Hopefully you've done the right thing on the two-pot system, but we're taking it a step further this time around. We're introducing a three-pot system for today, where the session will be broken down to 3 sessions, 3 blocks of speakers, so three-pot system in a way. and that's how we're going to carry it for the rest of the day. My job today will include a lot of reading, so please bear with me as I will go through all the bios as I introduce all the speakers. So please sit back and relax, prepare your questions. I think this is a new field for everybody, and it's an opportunity to learn and acquire as much knowledge as possible. So you can kick it off by introducing our first speaker. Is it down here? There we go. So for our first speaker, we'll be introducing Engineer Monde Soni, who will be speaking on site selection and network planning studies. Engineer Monde Soni is an EXA registered professional engineer and a senior member of the South African Institute of Electrical Engineering. Holds a BSc Electrical Engineering degree from University of KZN, as well as a MSc Electrical from the University of Cape Town. He has worked as a power systems planner and a manager within Eskom Distribution, and is currently a chief engineer in power systems planning and specializing in load forecasting and analysis, bulk energy storage integration studies, renewable energy source resource integration, and microgrids. He is a member of the Council of SAIEE and the chairman of the SAIEE Power and Energy section. He was awarded the SAIEE Engineer of the Year Award in 2019. Ladies and gentlemen, welcome Engineer Monde Soni. You need this. Clip anyway there.
Okay. Thank you. Let me just time myself here. Okay. Good morning, colleagues. I hope I'm lucky. I'm the lucky one to be the first to speak for today. While everyone is still awake, I will try and do justice to the topic. So my role in this project was being a network planner, so basically doing studies and selecting the site. And I think for me to do justice to the topic, I just need to give you a bit of background so that I will go through the slides quicker. So I think in 2018, we started a working group where we just looked at energy storage integration, the studies that would be required, and we went through this exercise. There was no problem. You know, when engineers don't have a problem, they tend to create one. So there was nothing. There was no one said there is energy storage coming. And I think maybe a year or two later, then we're presented with the opportunity that the World Bank was going to fund a project where we need to do energy storage, or battery energy storage to be specific, in Eskom, on the Eskom grid. And that's where the real problem started. There were no templates, no grid codes, no technical standards. And then what we did, then we had to develop those as we were also developing the project. So what I'm going to do here, I will just fly through some of the, call it, artifacts that came out of that exercise. So don't worry, Chair, I'm also timing myself, so just in case. So in terms of introduction, so we all have experienced the word JET, J-E-T, which is just energy transition, which then was one of the catalysts for this project, basically allowing us to integrate renewable resource in a manner that is responsible transition and as we increase the share of renewable energy resource on the grid. And I think one of the very important points that they made is the second point there, that says the impact will be mainly seen on ancillary services, and that will include issues such as transient stability. We would have curtailment of renewable resource, system strength. I don't know if we have sorted the system strength though. Maybe to be honest, we have not. You can't sort that using inverters, as well as also flexibility. So there were many issues that we needed to deal with using this energy storage. Then we said, just at a high level, what kind of use cases do we need to put in place and derive from these batteries? So we had system level use cases, and we had what I call local level use cases. In terms of the system level, we have energy support, which is the first one, and also ancillary services. And all of these are basically looking at the system-wide perspective. But then also, at a local level, we had issues where you've got these lamps where you've got very high PV in certain areas at certain times, and you need to shift it to the times where it would be required by the grid. And also there were congestion issues at local level. There were issues of distribution infrastructure deferral that we needed to also resolve. So up to now, in terms of what has been done, I'm just going to share 2 programs, and these are now at advanced stages. And the first one is the SAIEE program, where, and I will share a spreadsheet, a table just now, where we then went into this exercise. Initially, we had, I think, close to 40 sites that we had to choose from. And it was back and forth, trying to choose where best can you put these devices so that you maximize the benefit. And we ended up with these sites. So as you can probably see here, let me just carry this thing with me. So we've got 2 sites in KZN, Pongola and Elandscope, and then there is one in Eastern Cape. It's called Melcote, and there is a few in the Western Cape there, and then also in Northern Cape. So we tested a number of use cases. So one of the objectives here was to actually use this more as a demonstration or almost like a pilot, so that we can learn from it, and the next rollouts can actually benefit from this. Hence, you will see on the next slide a number of use cases. Let me put this here. Oh, no pocket. So a number of use cases. Firstly, we've got phase 1 and phase 2, and we've got use cases here for each site. We try to diversify in terms of what we are going to use this energy storage for. Now, if you look at these use cases, AS is ancillary services, ES is energy support, as I've just described earlier, and then you've got load shaving, and that is more now on the network level. If you've got a problem on the network and you do distribution deferral, we'll call that load shaving, and then also there is reactive power support use case as well. The one we are talking about today is HEX, which is this 20 megawatt, 100 megawatt hour battery. And as you can see, the use cases that it has is energy support, it's ancillary services, it's also there to be applied for the congestion relief at the local area. So over and above this SAIEE program, and I think Crescent will talk to this in more detail a little bit later, we were then also fortunate enough to be involved in what we call SIP1, which is the IPP program that's managed by the IPP office, the first bid window, which basically took a lot of lessons from what we kind of achieved using the ESCOM BESS program. So on this one, this is not ESCOM. As I've said, this is a public bid program. So we ended up with, I think, 5 sites with those sizes that you have there. A typical size was a 4-hour size, which also took a lot of lessons from what we had done. Now, in terms of now the planning, just coming closer to planning, the capacity studies that you need to do when you are doing BESS network studies. Firstly, in terms of your assumptions, you need to make sure that you cover use cases at system level, as well as, how do I point here? Does this thing? So, yes. Okay. I don't know if I should trust you now.
That's a pointer.
Oh, okay. Yeah, no, it's not working on the screen. Yeah. It's working there, just not here. So, okay, so when now just coming back to planning, in terms of your assumptions, you need to have your use cases evaluated at system level as well as local level. This I've already explained. And this is a process that you follow when you do studies. I cannot go through this step by step. It's quite, I think what I just want to mention, the process of doing energy storage studies, grid impact is extremely involved as compared to your normal IPP or normal generator process, because there is also an issue of time. There is also time series studies that you need to perform. So we actually put this together from that working group that had no problems, and we created problems. Then now the problems came later, and we actually we already had the solution. Now, in terms of the evaluation criteria, still doing your planning studies, you need to make sure that the grid code, which fortunately now we have. At the time when we did this, there was no grid code. You may ask what we did, so there was a lot of thumb sucking. So now there is a grid code, so make sure that you, all your applications do satisfy the grid code, and in terms of a voltage regulation limits, as well as your thermal limits, you do not violate the network limits. Okay. So now still on the evaluation criteria, there is something that makes a lot of developers in the energy storage space, makes them very, very scared, and they all flock around the MTSs. They all want to have the lowest of that thing, and it is called rapid voltage change. So this little monster here is to be minimized as far as possible. The impact of it to the grid, especially when you apply ancillary services, is that you can see fluctuations in terms of voltage on the grid as you apply energy storage to control frequency at a high pace. So rapid voltage change, we've got limits. We've got limits, general limit, which is 5%, but then we also have limits that are applicable to ancillary services. So what this means is for these ancillary services or these reserve types, for the instantaneous, you've got a limit of 4% that you need not to exceed for you to provide that, and the limit is very stringent for regulating because of the number of dispatches that you need to do. And then we also have these different categories. I think these are very much aligned to what we have from the renewables code. To manage the quantities and the amount of work that needs to be done, we replaced some of the studies with worst case points that you can just evaluate. So I can assure you that if you test those worst cases, you will not need to run your time series studies, because they will give you the answer, the ultimate answer that you're looking for. One of the artifacts that came out of the project was this capacity confirmation sheet. If you are a consultant in energy storage space or you are a developer, you may have seen this, and it's also, I'm sure it gives some of us, chest pains a lot, but basically it's a summary of all the outcomes of the capacity checks that the planner has done. So another set of artifacts that came out of the project, we revised the application form, which is your IPP application form. We inserted that highlighted text there. So that's how easy it is to revise a form. No, I'm joking. We actually went in, and there is a lot of content that was updated inside the form. We then, through the industry expert team, also contributed to the grid code formulation, and a number of these technical standards actually that are currently being used to evaluate projects in the industry. As I'm saying there, many, many more of those, they came out of this exercise. So just coming to the project, to HEX itself, how did we identify the problem? So we started with this as a, this is as a canvas. We looked at the network where HEX would be established, and the first thing that we saw is that we are, in a short term, we're going to have constraints there on the corridor between HEX substation and Bosclov substation. So we are going to have thermal constraints. That was the first thing. And then we started digging in a little bit deeper just to see what the profiles look like. And very interesting data came out. We saw that we've got a winter profile and a summer profile. So normally you would expect this to be summer, to be winter, because it's higher. This is actually summer, and this is winter. So winter is lower at HEX than summer. So we saw that we've got this big headroom, in terms of the difference between the two seasons. And also, in this summer season, we've got a peak that lasts for something like 10 hours. I think when we did deeper analysis of this profile. And then also, we realized that we've got voltage regulation issues at HEX substation itself. So these were the local issues that we actually saw. And then, through a number of iterations, then we came up with the use cases. So these use cases had to be split into the first table talks to now, before the constraint happens. And the second table talks to when the constraint has happened in that corridor that I was making reference to. And also, because of the complexity, we had to split the use cases into seasons. So we've got winter use case, and then we've got summer use cases. So, and also the reactive power support because of the farming load that, during those peak farming seasons, then those motors start to act as, an inductive load. Trying to conclude now. We then went through the studies that I mentioned earlier, and the scope that we put in place was, this is HEX substation, that is 132, this is 66, and you've got the 11 kV bus bar. We had these transformers that were smaller, and we realized that for us to solve the problems that we want to solve, and to also to contribute towards the national use cases, we needed to upgrade these guys here. So these were part of the scope, and then the BESS was established on the 11 kV with the POC sitting there on that breaker there. Now, in terms of the studies, I mentioned thermal, voltage, volt-VAR support control, which was very important, that volt-VAR support control, just to make sure that we've got varying voltage profile in this area, which at one point it's extremely high and at some point it's very low. So all were found to be compliant. You know, all these, the above aspects were found to be compliant, and also the BESS does provide, according to the planning studies, again, provide the relief that is required on the Boschkloof corridor. And lastly, this allowed for staking of benefits. So what we wanted to achieve here was to demonstrate a case where we've got a staking of benefits and we are solving local problems as well as contributing to the national grid. Thank you. I think I will end it here. We still have 50 seconds.
Thank you very much, Engineer Soni. Stay put. I think we'll open up the floor for a few questions while you are here.
Thanks. Mr. Soni, I've got two questions. The first one is, Eskom is being divided into three, there's distribution, there's generation, there's transmission. In which division will it be? Because some of the BESS is on the distribution side of the network, and I presume some of them are in transmission. And I know there's talk of, well, it's seen as a generation. So I'd just like to know where it fits in.
Yeah.
Then the second one is to decide where the BESS needs to go. Is it really that important? Because we'll need BESS. And should we not just really at a high level see where do we need BESS, and you put them in there, and it's modular, so if you see that you need to expand, well, you just put more modules in. Thanks.
So let me start with the last question. To decide where you need it, I think the main thing, firstly, you need to know what you want to solve, the problem that you want to solve.
Why is that relevant? Because it's 4 hours, it needs to comply to the grid code.
Sure. You may have seen the use cases that I made reference to here. So if you were to put this BESS in another, let's just say you put it at a bus bar next to the power station at the MTS, the 400 kV bus bar there. So the staking and the benefit realization that you would make out of that battery, there is no need for all that, you know, those local issues, because you've got enough network and you've got enough network strength, etc. So what we had to do was to just make sure that we benefit as much as possible. We use this to demonstrate that you can actually derive a number of benefits from one facility. This site selection, it had to be done very, very carefully. And as I've said in this case, there is a number of them, to the point where in certain seasons you can use it to sort out the local problems, but where the system is mostly constrained, and that is in winter, then it is actually available to sort out the system problems. However, now, if I think your question needs to come in when the IPP office presents a little bit later on. When it is not being developed by Eskom, which is the NSP, being developed now for the system, and it's going to be contracted through the single buyer office, and that's the DMRE process. That is a different requirement, because even the use cases that they give you there, they give you energy as well as ancillary services. So even with that, you still need to make sure you locate it in areas where there is more that you can get from it. You've got transient issues on networks that have got high PV, got voltage rise at certain times and voltage drop at certain times. So you need, while you are sorting out the national problems, you still need to locate it. So locating it is a very, very important aspect of, you know, of the studies. But then your first, and also my manager is here, he will talk a little bit later. Your first question was?
Distribution, transmission.
Oh yeah, it's a, this is a distribution facility. So the owner and the operator is distribution. But as probably most of you may be aware, we are moving towards having a DSO as well, which is distribution system operator. So the dispatch of these units will be done in conjunction with the system operator. But Nobisa will probably talk more on something like that. But the owner and the operator is distribution.
And all the BESS is on the distribution side of the network, nothing's on transmission side.
By the nature of the network, so you've got transmission, which is above 132, and you've got 132 and below, which includes collector stations. So you need to connect it, on the collector network, which is now operated and owned by distribution. So it sits on the distribution network. But the dispatch, especially for those ones, the system, the ones that are procured via the IPP office, the system operator has a full control on those.
Thanks.
Yeah.
Please explain the rapid voltage change a bit better to me. Is this something you don't want the BESS facility to do? What is it?
Yes. Okay, so what happens is if you've got a plant and you change the power suddenly at the terminals of the plant, and now I'm talking, it can be a load or a generator. So when you change suddenly the power at the terminals of that plant, then the network tends to either experience a shock in terms of the voltage going down immediately, and it takes time to recover. Or if it's a generation, then you experience that shock where the voltage will swell for a very short space of time. Now we've got limits to allow that. You can't avoid that happening, but it needs to happen within limits. That is what you call rapid voltage change. So in a case of a battery energy storage, the application of ancillary services at a short space of time, ramping it from 0 to 100% of its capacity in a short space of time, either applying it as a load or as a generator, you can now imagine what will happen on the network. That's what it means.
Thank you very much, Engineer Soni. There are no further questions. We can move on to our next speaker. While we prepare that, Engineer Soni spoke about engineers creating problems to keep themselves busy. There's one I noticed here that we need to solve as engineers. The pointer doesn't work on the screen. Engineers, you need to work on that somehow, sort that out. But while they're setting me up here, maybe I must just say a few words. I think it's a marvel to see the technological advancements that have been developed in trying to solve the energy challenges in the world. And this is one of them, and it's very good that we are trying to we're keeping up to speed, or up to track with the rest of the world in terms of energy requirements, resolutions there. So very well done, Engineer Soni. I come from an age where what led me to becoming an engineer, we used to play with electric toys, electric toy cars and blah, blah, blah. And you'd find a 9-volt battery in the car, and to check if the battery was still operational, you'd put on your tongue and you get a little... I don't think you can use that to test this battery, right? All right. Our next speaker, who will be speaking on design and specifications and project engineering, Engineer Thomas Jacobs. Engineer Jacobs is the Chief Engineer in the Distribution Division of ESCOM. Oh, it's not presenting. There. Okay, sorry. Engineer Thomas is a Chief Engineer in the Distribution Division of ESCOM. He's responsible for the technology management of standby power systems, energy storage systems, and microgrids. He's a registered professional engineer with EXA, 28 years experience in the electrical utility environment, and a lead engineer for the distribution BESS program. I had the pleasure of working with Engineer Jacobs with the HEX BESS. We're installing a PMU there. It's working finally. if you need data, I can now give you data for that PMU. But ladies and gentlemen, please welcome Engineer Jacobs.
The one, yeah, that's my name, yeah. Let me just see something here. The pointer. Just go right click. See it? Okay, good. Hi, good morning, ladies and gentlemen, and thank you for the opportunity to share with you today our BESS program, and also specifically, you know, lessons learned at the HEX project that we did, and also other projects which I will briefly share with you. So normally when we talk about lessons learned, I think sometimes it comes up, you know, as a negative, where we think, but what went wrong and why did you learn that specific lesson? I think today it's for me, it's about the positives as well. Now, what went wrong and what are the things we need to fix, but also what worked well and what are those things that we need to, you know, continue to do when we execute these projects. So I'll share with you the HEX BESS overview, the plan, and then some lessons learned on executing the project. So my colleague Monde shared this slide with you earlier about the different services that the BESS can provide on the network. We mentioned ancillary services, energy support, load shaving, reactive power support on the network. And as he mentioned, you know, it depends on the use case where you would place it on the network. The gentleman asked if we, you know, only going to do it on the distribution network, but on the generation side, there's also the repurposing and the repowering of Komati power station, where they're also going to put a big BESS plant there. So there's also other power stations where we will be implementing BESS in Eskom. So this is just to show, as Monde mentioned, there's two phases for the project. The first one would be the 198 megawatt that we're going to do, and the second one, 146 megawatt. In this first slide just shows you where the location for the first phase of the sites. The one that we will be talking about today is HEX, which is located here in Worcester. And so this is our site at HEX. But we are also doing other sites, like for instance in KZN we are doing Pongola in Elandskop, which are also close to being completed. So this is our Elandskop site. And this is the site at Pongola, which is also a big site there. You can see at the moment that's the biggest one. But we're also doing sites at, if I can go back, at the moment we are constructing sites at Skarpvlei, which is at our wind farm, and then also Gravate and Paleisievel. So there's 3 other sites that's busy in construction at the moment. Okay, so this will be our phase 2 sites that we're going to do as well. So overall, we will have an installed capacity of 343 megawatts. So just a little bit of history about HEX, the HEX site. In the past, it actually used to be a coal-fired power station. So that site was decommissioned in 1988. And the site is located in a small town called Worcester. And at the moment, that's the 3rd largest city in the Western Cape province of the country. And there's mainly agricultural and residential loads that's supplied from this 11 kV network. So this is just showing you the single line diagram. And if we look at the duty cycle or the use case that we're going to use HEX for, is we will be, this one at the moment we're using it for energy support, or peak shaving, national peak shaving. So we charge the batteries overnight when the time of use tariffs are low, which typically is about 6 hours. And then we would discharge the battery in the morning peak for about 2 or 3 hours, depending on the season. And then the evening peak, the balance of the hours would be discharged then. So the primary use case for BESS at HEX would be ancillary services, where we will provide network support services to our system operator. And then the secondary use case would be the peak shaving. Now this is, Monde mentioned that there, in future there will be a constraint, a thermal constraint on this line here, the supply line. After that constraint happens, in future we will do local load shaving at the site. And then the secondary use case would then be ancillary services and energy support. So this is just a high level a block diagram of the system. We've got the BESS on the one side, which are our energy storage devices and our power controls, power conversion system, the PCSs. And then we've got the network integration equipment, which is our power plant to integrate this system into the network. And then obviously we also have our control plant systems to protect the site, to control and manage the system, to make it do what it's supposed to do on the network. So I just added a table here just to show you, you know, that if we look at this site, which is actually akin to a pump storage scheme in our distribution network, you can see that it's got equipment that comes from every corner of the, so different people working together on this project, which makes the project so much more complex. So if we look at the hex, there's the substation side that I've uncovered there. The substation, it shows the 2 transformers that were upgraded. And then it also shows there are 11 kV switch room, which is also our point of connection. That's 11 kV indoor switchgear that's located there. And then on the other side, we have our hex plant, showing the different components in the site, which I will go through now as well. So if you look at the site, the site is divided into 6 bays, or which we call also battery banks. We've got a control building. We've got the auxiliary transformers that provides auxiliary power to the site for our control and management equipment, and also our HVAC equipment on the battery systems. And then from there, we've got the ring unit. So you will see that each bay is the ring main unit, and this forms the ring. So the ring main units are connected together, and that connect to the bays to collect energy. And then we've got 4 11 kV cables going, which terminates on our point of connection on the substation side. So you can see if you look at the design, it's a scalable design, and it's also modular, which means that it increases the reliability and also the availability of the plant. So we can take out a portion of the plant for maintenance purpose, and the rest of the plant can still be functional to provide the necessary network support services. So if we zoom into one of the BESS bays, we start off with the ring main unit, which is 4.4 MVA. Then we've got a step-up transformer or a step-down transformer, depending if you're charging or discharging, which is also called our inverter transformer. So when we did this project, we had to develop a special specification for the inverter transformers because of the power quality or the harmonics that's generated by the PCS system. So you can see that this inverter transformer steps the voltage from 11 kilovolts to 619 volts AC. That voltage is then fed into the PCS, which is a bidirectional power conversion system rated at 4.4 MVA, and that then converts the voltage to 1.3 kilovolts on the DC side. So the battery bank is divided into 4 strings, as you can see there. And these things need to be supplied, or these battery racks needs to be supplied with auxiliary power. And that's where the ACC comes in. That's the AC combiner circuit. And that supplies UPS power, which is backup power, AC power to our controls, our battery management system on the battery racks, to our fire detection and suppression system in there, and also for communications on that system. It also provides normal AC power for our HVAC equipment in the battery racks, because it needs to maintain the temperature at around 20 degrees, 20 to 25 degrees, to improve the life expectancy of our batteries inside. So the next system or the cabinet that I want to talk about is the DCC, which is basically the DC combiner circuit, and that's basically just a bus bar that connects the outputs from all the battery racks together in one bus, and then from there, it then connects to the PCS. You can see there's 4 cables going to the PCS, or pairs of cables, DC cables going to the PCS, to the different modules inside the PCS. So this PCS is divided into 4 power control modules, or power conversion modules. And each rack is 376 kilowatt hours and 280 ampere hours. That's the capacity of the rack. And as I indicated, it's 4 strings. So you can take out a string for maintenance and the other 3 will still be able to provide power. So collectively it forms a bank, and on the side, as I indicated, there are 6 banks. With the first 5 banks got 56 racks, and 50 racks are in the 6, located in the 6 bank. So in total there's 330 racks on this facility, with a rated installed capacity of 123 megawatt hours. This is just a single line diagram to show how the different parts of the system is connected. So there you can see the PCS and the 4 collectors that basically terminates in the PCS. And this bus bar there is just showing you the DCC, the DC combiner boards. Okay, so this is just photos of the PCS. So the energy storage chemistry that we use is lithium iron phosphate. And inside, if you open up the cabinet, you will see there's 8 battery modules which are all connected in series to give us a total bus voltage of 1.3 kilowatts. So this slide just shows the different form factors in which you can get cells normally. So you will see you get the button cell, cylindrical, the prismatic, and the pouch. The technology that CATL uses is the prismatic one, or which is employed in the Eneron battery cabinet that we use at HEX. So you can see that from cell level, they are connected. In this case, it's 52 cells in each of those modules, which are collected in series to form the module. And then those modules are also further connected in series to form the rack. And those racks are then all connected in parallel to form the total system. So these slides talk about augmentation. So augmentation is necessary because over the life of the battery you lose capacity. So you lose the amount of energy that the battery can actually hold, or useful energy the battery can hold. So if you think about your laptop, when it's new it lasts 4 hours, 5 hours. When it gets older, the standby times gets less and less. So the same happens on this lithium ion technology. So the contracted capacity for HEX for 20 years is 100 megawatt hours. It's a plan that should provide. We're starting off with 123 megawatt hours. So over time it will lose capacity, and we need to maintain that capacity above that 100 megawatt hours. So this is where we're going to do augmentation. So the plan is to do augmentation every 5 years. And I must also mention the rate of capacity loss obviously depends on the use, how you use the battery, the temperature, the environment in which it's operated. So those are all things that we need to take into consideration to achieve the expected 20-year life out of this facility. So you will see that on the side we've made provision. So there's extra space at the end of each bay to allow for these extra cabinets to be added. So the augmentation strategy that we're going to follow is that in Bank 6, I indicated in the earlier slide that there's only 50 racks in there. So every 5 years we go every 5 years we're going to augment. So we're going to add new battery racks to this plant, and this is the location where we're going to add that in Bank 6. So what we're going to do for the first 5 years, or in year 5, we're going to remove one of these things and distribute it to the ends of these other banks, which leaves space open here, and where those the empty space is created, that's where we're going to install the new battery banks. And we're going to do that every 5 years. So how that's going to work, or why we're doing it that way is because you're adding, remember these batteries are the same age as the others, so you're just adding it to the you know, a battery of a similar age, and the new batteries are installed on a string on its own. And that's how we're going to solve that issue. Okay, so the next section of the presentation is to discuss the lessons learned. What are the key things that you need to consider when you embark on a project as complex as this one? As I said, it's like building, it is actually building a power station. So if we look at the value chain, there are 6 things. There's a planning that my colleague Monde covered, which is key to locate the location or the best, at the best spot on the network. The concept design, where my team comes in, and the inquiry, the execution of the work, the operating and maintenance, and you know, decommissioning the plant at the end. I want to focus on this one from the onset. Operating and maintenance is where we're going to get the return on our investment. So whatever we do now in the beginning stages should serve the operating and maintenance staff, the people that's going to operate and maintain the plant. So the decisions we make early on in the design process is key to make sure that, you know, that they can do the best that they can do with the plant, and we meet our design objectives. So the BESS is a complex project. Implementing this, it involves many stakeholders across the value chain and many different engineering disciplines. So behind this project, there's a lot of great engineers and, you know, other stakeholders, other people from other disciplines that worked on the project. And success factors that stand out for me, firstly, is around clarification. Everyone should know exactly what they need to do, when they need to do it, and how they need to do it. Not only on the, you know, on the employer side, but more importantly on the contractor side. Coordination, communication between the different stakeholders are key. Controls need to be in place, because in the beginning, when we plan, you know, in the early stages of the projects, there's a lot of people involved. You've got a lot of control then. As the project matures, the control becomes less and less. There's different stakeholders, different objectives, as I can show you with this, you know, the bullseye, the many arrows, everyone aiming for the bullseye. And everyone's got different objectives, and it's important that project management makes sure that all of those objectives reach the bullseye. So you need to maintain focus over this project. The longer the project is, the more people lose focus. So you need project management needs to make sure that focus are maintained. And important upfront, you need to do a gap analysis, not only about the project, but also about, you know, operating in maintenance, especially if you look at the new technology that you're implementing in the business. You need to look at what are the resources that we have today, what are the resources that we're going to need in the future, in the near future actually, especially when you want to operate and maintain this facility. So all requests needs to be properly accounted for in the contract. That is so important that I learned in, you know, when on these projects. It's actually my first big project that I worked on. Because remember, when things go wrong, you can say what you like. We're going to look at what does the context say. So it's important that we make sure that we address all of these things in the context. So from scoping the project, we started off with what are the functional requirements. I hope that we're going to get a consultant, you know, to do all the nice work, develop the specification. But our management said, no, you're going to do it. You're going to find the answers. You're going to write the specification. You're going to decide for the business what needs to be done. And I'm so grateful for that opportunity, because I can say that that's the best way to learn, to actually do it yourself. So if you look at all the stakeholders, I mentioned O&M, control and monitoring staff, because this plant needs to be controlled from somewhere by people. What are the regulatory requirements, the OSHEC, the grid codes? You need to take that into consideration. Capacity building, especially want to maintain and operate this plant in the future. which I think is key. I think that should be, one of the important things. Augmentation or upgrades that would be necessary for the plant, you need to make provision for that upfront. And then also, once a plant is, during construction, safety, the safety aspects you need to take care of, but also when the plant is operated, the emergency response plans that needs to be put in place. There are first responders that needs to, react when there's an emergency on the facility. BESS plants, you might know, these things explode if you don't take care of them properly. There's a lot of cases internationally where we had explosions where first responders were injured. So it's key that we make sure that these are part of our plans when we commission these sites. So normally people talk about the, the black box approach. You say what you want to go in and what you expect to get out. We decided to go the grey box approach. So we wanted to have some form of control over what goes into this facility, because in the end, it needs to integrate with our network, with our processes, with our people. So what we decided as an employer is to make sure that we implement employer standards, systems, processes, and guidelines, and you make use of standard equipment that our staff are familiar with, especially if it's common equipment that we use in the substation environment. Things that we did not know, new equipment, like for instance the energy storage, the PCS, those were non-standard equipment, and we allowed the contractor to propose what are their technology, so that that needs to be implemented, and what are the other accessories that needs to be implemented as well to make this technology work. What we decided also is that we're going to only select proven commercially available technologies. Now for this project, we didn't specify a technology that should be used. The only thing we specified, it should be an electrochemical technology. We gave the boundaries, like the size of the land that's available, what we want this thing to do. And the market dictated, and they showed us what would work on this site, given those constraints, and also at the best price. So also key is you need to decide on the life cycle management strategy that you're going to follow. In our case, what we decided, because it's a new technology for Eskom, we decided that we're going to have a 5-year operating and maintenance contract, because normally, to train new staff, especially for new technologies, takes time. So we wanted that room to be created for the company to bring the right people on board and give them enough space to get familiar with the technology. So we decided that we're going to use in-house resources. So the contractor is on site for 5 years to sort out teething issues, especially when it's new technology. And I can tell you there are teething issues that we're experiencing at the moment. And I'm grateful that we have the suppliers turn around to fix these things and to work with us to do that. And they're doing an excellent job. So the approach that we followed when we issued the inquiry, we decided normally, so there's 2 options, there might be others. You decide you're going to own the facility in the end, and you're going to operate and maintain it. Or you just, you buy power purchase agreement with the supplier, where the contractor or the IPP is responsible for everything else, you just pay for the energy you get. We obviously decided to own the facility. Our execution strategy was EPC, where the contractor had to engineer, procure, and construct the facility. And the contractor had to offer a solution that meet the following functioning requirements: the power and energy capacity that we wanted at the point of connection, because that's our reference point. The identified use cases for the project. As I mentioned, it should have been electrochemical energy storage technology. All equipment had to be type tested, which means that gives us the assurance that, that this equipment has gone through rigorous testing, and it met, widely accepted technical standards, whether it is IEC, IEEE, or UL. In our case, we couldn't even specify the standards that it had to meet. So we had to go back and decide, but what are the functional things? How are we going to use the system? And what are tests that would give us the assurance that this equipment would work well in its operating environment. So we did, let me put it this way, we did specify specifications, but we said that if the supplier offered the equipment, they must prove that the tests done on those specifications, similar tests were done with their specifications. You know, if they tested it according to Japanese or other country standard, that the tests that were done were similar to the ones that we specified as our standards. And as I indicated, it had to fit on the provided footprint. So we also said we must implement standard equipment, especially on the control plant side, because it needs to integrate with our control systems. On the power plant side, we couldn't really specify that, but it had to meet our ESCOM specifications. And as I mentioned, the 5-year O&M contract. So if we look at the inquiry, key is to plan up front properly. You know, spend the time now before you go out an inquiry to plan the evaluation process. Design your technical schedules that the contractor needs to complete to make evaluations efficient and effective. Because you've got this one opportunity to ask all the questions, so that when you need to make a decision, normally you cannot go back to the market to ask for more information. So you want to be in a position that you can make an informed and the best decision based on the information provided. We also ask the suppliers to provide the information, especially supporting information, in a folder structure so that we can easily find where the evidence are in their submission. We had a tender clarification meeting, which is key, so that suppliers understand, firstly, what are our requirements and how they need to complete the tender documentation. Gave them a checklist so that they can also check to make sure that everything are provided, because in some cases there are mandatory information that if the supplier does not provide that, they are excluded from further evaluation. So just to make sure that everybody got a fair opportunity for their tenders to be evaluated. One other thing that I noticed then, when you evaluate tenders, is you ask for a test certificate for the offered solution. Sure, the supplier gives you, this is the equipment they offer, but then in some cases they give you a test certificate for other equipment, not the ones they offered. So as an evaluator, it's key that you make sure that there's matching the equipment they offer, the types of certificates are for the actual equipment they are offering. Also, as part of your evaluation process, it's important to keep notes and of the decisions your evaluation team is making, and also to make sure that you note conditions that needs to be negotiated on before the contract is awarded. So the people that downstream does the negotiations, that they know what are the conditions from an engineering side that they need to include in the negotiations before they award any contract. Also keeping good notes of your evaluation process is key, because especially when your process has been audited, normally it's about 6 or 8 months down the line, you've moved on to other things, and it's difficult to remember. So that's where your report comes in handy in your documentation, so that you know why you made certain decisions. When it comes to execution, it's important to know each other and agree on the rules of engagement between you and the contractor, who's going to do what, how are you going to communicate. Project integration management is key, because there's so many disciplines that needs to work together in sync to achieve the objectives. What I found, what works, especially when you work with overseas suppliers, is to overcome language barriers. It's maybe key, something to consider, to use locals as part of that project management team. Because what happens in your meetings, you might ask questions, decide on something. That local representative from your country could then, behind the scenes, go in, explain to their contractor or the supplier what's the issue and how they're going to solve it. They also understand the local environment better. What are the things that you can do to prevent delays? It's important that you agree up front as a project management team. formatting of artifacts, especially when you work with in ESCOM. There's a lot of formatting that needs to be done. Things need to be, formatted in a certain way. Documentation, reports, processes that needs to be followed, procedures. There's a certain way that we do things. And the reason for that is because our staff understands how, how can I put it? They understand, they've got a certain way of doing, working and following certain processes. So you need to make sure that, that whenever your supplier presents something to you, like for instance, drawing, there's a specific standard for technical drawings in ESCOM. You need to make sure that you agree up front and that they know how to present it in that way. You also need to make sure that your people, especially when your internal team is going to review the designs from the supplier or the contractor, that they are ready and available to be able to do that in order not to cause any delays. You need to make sure that they understand the internal design approval process. And also, I think what is key is an effective and efficient transmittal management system. When the supplier sends you or the contractor sends you something, you need to review that and you need to provide an answer. There's normally a back and forth between the parties. So you make sure that, that process is efficient and effective, and you don't lose information and need to redo stuff. So that's key. Also, you need to agree up front. What's the handover pack list? What do you expect from your contractor at the end? Is a full list of information, drawings, artifacts, procedures. And you need to think about the downstream activities, the operating and maintenance activities. So while you do the project, the focus on getting this plant operational and built, but you need to think about what's going to happen once it's built. There should not be a standstill. The plant should be handed over to the operating and maintenance staff. So you need to make sure that those documents or processes are also put in place, and my other colleagues will talk about that later. So it's important to align different activities to limit, variation orders, things like standing time, equipment storage. So it's key that you schedule the project properly to prevent those things from happening. Also, when you do commissioning, testing and commissioning, it's important that the teams are operating and or the OEM teams that come and do this are on site. People, different time zones. When you commission a site on the day you're tested, you can't wait for the guy the next day to wake up before you do the test. You want everyone to be here and actually do it and to sort out the issues. That prevents delays. And as I mentioned, when you implement new technologies, you need to couple it with an operating and maintenance contract to make sure the contractor is around to sort out teething issues. Something from our design review team, the key things that we look at when we design a project, even from concept phase, we look at, is the site or the design constructible? Can we build this thing? Are we able to buy these things, How are we going to operate these things? Is it operable? And not only operate it, but can we operate it safely? How are we going to maintain this thing? Will we have spare parts available? All things that you need to think about. Will it be easy to be maintained? Will we have the necessary skills to do this? And then sustainability. Will this thing, once it's built, be sustainable into the future? The expected life is 20 years. How are you going to accomplish that? What are the things you need to put in place today for that to happen? What are the reliability aspects? Things fail. How are you going to make sure that once it fails, that there's a backup to make sure that the objective is still achieved? And how important is the plant to the network that it's going to serve? Availability. Is it dependable? What's the probability that it will operate as required when required? Is it inspectable? Will our maintenance staff be able to inspect it when they commission it? Testable, from factory acceptance, site acceptance, commissioning and maintenance. How are we going to test things that you need to consider? Extendability, is the site scalable because the use case might change in future? Is there, allowance for that? Is it is it future-proof? In future, there will be new technologies. There will be energy storage technologies with better energy densities. Will we be able to integrate it into the system? And then last, how are we going to decommission this? Although it's 20 years into the future, but what are the things that exist today or that we need to take into consideration today to make sure that when the time comes that we need to decommission this plant, that we are able to do that safely and effectively. Thank you.
Thank you very much, Engineer Jacobs. Just a question from my side, really. You've spoken about how you're going to embark on installing more BESS sites across the country. And over the last couple of months or so, we've seen how solar panel prices have gone down. I'm just not sure if it's because of load shedding or it's because of manufacturers in the playing field now being increased. But are you seeing the same trend in terms of pricing for batteries?
Yes, no, definitely. When the battery prices went down, when we actually issued this inquiry, the battery prices went up. And it went up very fast. So what was key for us is to place our orders because everybody wants to place orders because the price went up. So it was basically a big deal to make sure that we get it at the best price. Since then, prices has come down again. At the time, there was a lot of issues, logistics, that, the increase in raw material costs that made the prices went up. So, but we can definitely see that energy storage prices are coming down. So, yeah, definitely.
Thank you for that. Got a few hands for Engineer Jacobs. I'll start this way. Yes, sir.
Okay, thank you for the presentation. I have two questions, the quality question and analysis question. So from the quality perspective, you mentioned that before commissioning, you do test the batteries, right?
Yes.
And then one of the respondents got injured. And with lithium-ion batteries, you don't need one battery that is defective. You just only need one cell that is defective and propagates as a thermal runaway. So I want to understand what is your testing processes, and do you hire an external contractor to do that? That's from the quality side. From the analysis side is when you plan the system, as you mentioned, you have your goal and to say you want the system to do this. So first of all, you do model the performance of the system, and after that, to analyze the system, you download the data after some time, and you compare the data, the operation data, with the model data, and see the deviation of the plant.
Mm-hmm.
What deviation have you seen so far? And as a follow-up to that question is, what technical issues have you came across in the past?
Okay, let's start with the last question first. So sure, so this plant has been operational for about 6 months now. Okay. So what we're doing now is to basically fine-tune the plant to see what its capabilities are in terms of round-trip efficiency, what are the issues, what's failing at the moment, so that we can get indication of what the typical things are that we need to look at and make provision for in the future. So at the moment, we're using the plant for energy support or peak shaving. Okay. So that's only the one use case. So we, as I said, monitoring that. In future, or in the near future, probably in the next month or two, the plant will also provide ancillary services to our system operator, which is fast frequency response. And my colleagues will talk about that a bit later. So we're still monitoring the plant to, to see how it should work, what's the best way to operate the plant. what I must say is we had an issue a few months ago, yeah, where we actually, the batteries were over-discharged to such an extent. Now there's 330 racks on the facility, such an extent that we could not use the PCSs to recharge the battery. Okay, so obviously that's a big thing, because what needed to happen is the contractor had to go and manually recharge each and every bank, and that took them a few months, actually a month and a half to do that. So obviously that was important for us to find out what's the root cause and how are we going to prevent this, because we're building 2 other plants as well in the KZN area. And the contractor were diligent, they sorted out the solution, and what they found is that the communications between the different equipment on the site, remember there's an energy management system that tells the plant what to do. Then there's a power plant controller that actually sends out the instructions to all of these devices, to the PCSs, to the battery management systems. And then it tells the plant, okay, the plant reacts to that. But there was a communications issue. It couldn't communicate fast enough to the PCS to tell it to shut down, not discharge anymore. So that thing is fixed, and that's how you learn how to operate, especially new technologies. And that's the value of having a contractor around for operating and maintenance. Then your other question was related to the fire. No, we didn't expire. We had a fire, but it wasn't at site. It was on the route to site. That's where one of the trucks, the hose of the truck actually caught a light. Not because of the batteries, it's because of a truck failure. So that didn't happen on our side. Okay. So we didn't have failures, touch wood, yet. But internationally, you won't be able to, if you go on the EPRI website, they keep a database of energy storage failures globally, and you will see that these things do happen. Even type-tested equipment does fail. So how do you make sure that, that the likelihood of that happening is reduced as best as possible? So make sure that you have the OEM come and install and commission these systems. Because remember, they designed the system, so they know what's the best practice in terms of installing, testing, and commissioning the system. And that's what we did. Yeah.
So, but the process of testing, how is it? What is the process of testing?
So they would, remember, they won't do a factory acceptance test. So they won't test the capacity of the batteries. Remember, these are type-tested equipment, which means the design has already been tested and proven. So they just build it according to the design. At the factory, they won't do functional tests to make sure that all the systems inside this rack works. It can provide the capacity, the safety features work, the charging and discharging, the fire detection systems are operational. At site, you would do the same. You want to make sure that the fire detection and suppression system actually does work and, the way it's intended to. Then you want also do the test to make sure that it communicates with the power plant controller and the energy management system, that your battery management system inside this rack actually collects all the data and reacts if the measurements goes outside safe ranges. And that is the voltage, the current, and the temperatures of each cell inside of those modules. You mentioned that there's a fire, a thermal event can be caused by one cell in a module. So those are one of the tests that we specify, that it's a thermal containment test. So if there's a fire or a thermal event in one of the modules, it doesn't spread to the other modules.
Awesome. Thank you. Yes, sir?
Thanks once again for the excellent presentation. Mine is a very simple question. It's actually a follow-up from the earlier question about the comments. Are you able to comment on the technical economics of the project and how does it relate to the overall tariff?
The?
Overall tariff. So what did you get in terms of the price?
So my job was to build the project. so maybe that's the easy answer. But remember, it's key for us. We spend a lot of money on this project, on this investment. And for us, it's important to make sure that we get our return on the investment to make this project worthwhile. And as Monde mentioned, Key for us is to make sure that the stack benefits are achieved for this project. At the moment, it's only one, but ancillary services would be the next one. We will get more revenues from this project. I cannot tell you, I mean, stand here today and say it's positive at the moment, but time will tell. We've got our teams working on it, and yeah, hope for a good result. But as I mentioned, my job was to build it. Yeah.
Thank you.
Thanks for the presentation. BESS is used internationally, and they're all 4-hour storage. It's not possible to just take a internationally accepted BESS system and just cut and paste and put it there. And given that you've got that 4-hour storage, well, it can do it can do all the services and the whole stack. And the system operator will just decide, well, which part of the stack we're going to use. So my question is, well, how much design do you need to do? You just cut and paste.
Yeah. So, no. You see, the thing is, it depends on the use case. In this case, for HEX, it's 5 hours, not 4 hours. And that's where the network planners come in. They analyze the network and see, you know, we've got this challenge on the network. What do we need to put down there to address all of these challenges? And they found out it should be an energy storage device. They didn't say what it should be. Our job from a concept design or engineering side is to decide which device will do what the network planners want us to do. So, and there's a lot of technologies. This is only electrochemical, there's mechanical, there's thermal technologies. There's a lot of other technologies that can do the same job, but maybe not at the best cost. It might not fit in the space that we had available. So there are constraints that you need to, work in the end.
Maybe just to add on to what he's saying, I think Monday will also be in a good position to answer that question, because he spoke about studies that they've done to sort of quantify what they actually need. Remember, he spoke about peak shaving and ancillary services. We need to look at the data for the frequency plots to see how much we need to actually assist in containing the frequency and all of those things. So it won't be a cut and paste. There's a whole analysis and work that's been done behind with the data that's available for us to actually get to the point where we can have a specific site that we've designed to that degree. Yeah. Yes, sir.
Thanks. So from a lessons learned perspective, in terms of your system design, we all know there's a lot of consideration given to transformers in networks such as this, in terms of harmonics, how you change your vector groups, all those type of things. What is the most important things that you could have identified in the transformer design that you see now on the plant and operations? So the fact that it's in a warmer area, that type of thing, is it functional for the area? What lessons did you learn?
Yeah, I'm not a transformer specialist, so I would lie if I tell you. But so we at our transformer specialists actually look at that. You know, what are the spec and the requirements that we use for our normal power transformers, and what are the the harmonics that you could expect from a PCS, and what transformer is, or the tests that should be done on these transformers from a type test perspective to make sure that it can actually handle those things. But I can't tell you. Sorry.
No, it was just conceptual. It wasn't detailed. It was just if there's something important that you learned, for example, that dry types, a lot of us know that dry types struggle in these type of environments. So something small like that.
But no, I don't know. But that's obviously some of the things that we do monitor as part of our project now, to see what works, what are the things that we can improve.
Great, thanks. Last two questions. I've got here. Okay.
Thank you, Engineer Thomas, for a very insightful presentation. I just have questions. How is it going with training of staff? Because after 5 years, you don't want to depend on a contractor or O&M. And okay, ancillary service question, you answered it, that you're still gathering data, because I wanted to know why is it taking long for us to use use it for ancillary services? And number 3, what is the operational lifetime of a battery, and what's going to happen afterwards?
Okay. Let's start with the operational life. Let's start with that one first. So the plant is designed for 20 years, so hopefully we'll get 20 years out of it. So it's 20 years. We're going to augment the plant. So we're not going to replace, obviously, everything after 5 years. What's on site will last 20 years. It's just going to lose capacity. So we're just going to install new racks to augment the capacity. So everything should last 20 years with proper maintenance. Remember, it will only last if you maintain and use it properly. So that's key. When it comes to operating and maintenance, so as part of the project, we've set funds aside for operating and maintenance, and then also as part of that, there's a whole curriculum that the staff needs to follow. Remember, there's our operators that needs to be trained in our control centers. There's the operating and maintenance staff on the facility that needs to take care of this facility. There is new systems that we never used in distribution before, because this is a power station, like the fire systems, the HVAC systems. So we need to train people to be able to do that. But there is a curriculum that we work in conjunction with the contractor to make sure that that everything is developed, that it meets our. In ESCOM, there's formatting for learning material as well, that we follow those guidelines as well and make sure that our staff are not only trained but also accredited to work on the plant without affecting the warranty conditions.
Awesome. Final question.
So one of the online questions from Nico Foster is, what fire suppression are you using in the battery cabinets?
It's an aerosol. I don't know what the name is over. So yeah. I don't, is it that, but I can, if I can check the question, and if they want to know exactly what the name of the chemical is, I can get that. Yeah.
Awesome. Last one.
Yeah, the function of the ACC, DCC, I didn't get that.
Okay.
And then one other question, would you say the battery base, there are effectively 5 strings, for augmentation, when you have to do augmentation? Would we say the space is designed for 5 strings?
Oh, okay. I'll show you that now. Is that it? So the first one is the ACC. So it's this thing here. So it's just like a normal AC distribution board. If you think about your house, the distribution board for electricity in there, that's what it is. The difference is that it also has, actually nowadays, you have the same thing in your house. You've got normal power, your normal loads. And if you have a hybrid power battery system in your house as well with the inverter, there's the standby load, so critical load. So that's exactly that. Yeah. The DCC is just, so a battery's got 2 terminals, a positive and a negative. So if you think about this cabinet, this rack is a car battery. Those 2 terminals are just connected to this bus. So it's all of these batteries connected in parallel, basically. So they come connect together at this bus. All those cables are connected to this bus. And from there, we just have one cable going to our PCS now, and the strings. When it comes to augmentation, which is this one here, so it will still be, so let's say we take this row here, and we say we're going to, after the first 5 years, we're going to take all of these cabinets, and we're going to put it at the ends of these. So we're just going to make that string longer. So if there's 10 cabinets there, I'm going to take maybe 2 of each, or 1 of each, and just put it at the back here, at the ends, okay? And then that space is empty now, so I'm going to put the new racks into that space now. And that I'll do every 5 years. That's the plan. Maybe just one other thing that I want to say. Sometimes when we design and plan, we plan a lot. I say just start, Do what it will not be perfect. It won't get better. There is always a ref 2, ref 3. You can always improve. Just start. Okay. Thank you.
Thank you very much. know there's possibly some other burning questions that are in the audience, but we can have, during the tea break, we can have one-on-one discussions to get clarity from our presenters. Once again, thank you, Engineer Jacobs. It's good to know that the batteries are still operating positive and negative, that my knowledge of battery technology is still valid. That hasn't changed. All right, ladies and gentlemen, our next presenter, Bongo's gone. Our next presenter is Engineer Ajith Prasad, who's going to be talking on operations and maintenance. I'm trying to find your bio. All right. Engineer Prasad has a master's degree in electrical engineering with 27 years service at ESCOM. Currently deployed at the DX Operations Enablement, Maintenance and Center of Excellence. Skills include strategic planning, change management, technology management, performance management, risk management, quality management, and maintenance management. A lot of management. Engineer Prasad developed the ESCOM DX maintenance engineering standards for the following: switchgear plant, HV overhead lines, MV and LV overhead lines, distributed energy resources, which is BESS and microgrids and PV systems. ESCOM distribution chairperson for the various care groups, including MV and LV overhead lines maintenance, LV performing management, BESS maintenance and operating, SSEG microgrid maintenance, switchgear plant maintenance from 2007 to 2017, HEX BESS O&M management chair for Western Cape operating unit since from February to April 2024. Ladies and gentlemen, please welcome Engineer Prasad.
Thank you, Program Director. Am I clearly audible? Yes. So thank you for this wonderful opportunity to speak in this prestigious institution. It's really an honor to be here, and thank you for inviting me to speak. So whilst he's bringing up the presentation, I'm basically representing the operations and maintenance departments of ESCOM distribution. So when I say that, I'm coming from the maintenance center of excellence, and so that's offering a strategic role, strategic oversight for maintenance and operating, where we develop the maintenance engineering requirements for our various assets. So you can see the heading says lessons learned. Now my colleagues have covered a lot of lessons that we've learned, but the thing is we are still learning as well. There's a lot has happened. We will probably make mistakes in the future. We are learning, and we're going to share some of those lessons with you. Okay? Contents of the presentation. I'll just touch briefly on the contract mandate. My colleague has mentioned the 5-year M&O contract. There's a document that we have developed that guides that there. We had some risks. I'll touch on that in January 2023. I've given some feedback as to what the challenges were. The governance progress as of January 23 as well. I'll touch on the operating and maintenance landscape. My colleague also touched on augmentation, and then the HEX BESS O&M project management. And you'll understand why I'm calling it project management. And that was a very short stint that I had there. And then the lessons learned thereafter. Okay. So I wanted to put this slide up, all right, because the project is about design, engineering, supply, construction, installation, testing, and commissioning of the BESS. But it also includes plant operation and maintenance services. Now, I've highlighted that because this project, it's not business as usual for ESCOM. We in the distribution space, traditionally a contractor or ESCOM would design and construct and hand over, for example, a substation or 5-10 kilometer power line, for example. But here we're not just handing over a piece of equipment, all right? Generally, when we hand over a piece of equipment, our maintenance environment gets involved and takes care of all the maintenance requirements and ensures that those things are in place before we take a handover. And in this case, the operation and maintenance is being managed or managed by a contractor. So it's different. And what we found that hasn't been effectively communicated in the organization because there were challenges as to who's going to do what, when, how, and when. So the role clarity was important. And I think that's the message here, okay? So I spoke about the 5-year M&O contract. We actually developed this document back in 2020, and it's basically covering, giving guidance on the contractor as to what to do, when to do, how to do, and who to do, all the different aspects of managing the 5-year O&M contract. But just to elaborate further on that, it covers the monitoring, the corrective maintenance, and the operating, typically the alarms. It goes on to preventative maintenance and the operating thereof. And then actual operations. Now, I'm not going to go into the operations, the details of the operations. My colleague Norbisa will cover that. But the O&M, the DSC SEC 19 document covers the operations in terms of the alarms, the actual operating itself, and then dispatching of resources, and more especially the dispatching of the energy itself. Okay? Now, I got involved with this project sometime in August, I think it was 2022. And at that time, we were obviously getting in, doing the designs and, just listening into the meetings and having this view of the ops and maintenance, what goes in, thinking at that time. So the challenges we had at that time, we didn't have specialized resources for the management and operation of BESS. And you'll see project manager. I'm going to speak a few times about this project manager. To bring all the bits and pieces together from an O&M perspective, and as I said earlier on, I highlighted the section for the O&M aspects. There wasn't an individual that was going to bring all these bits and pieces together from an O&M perspective. So we thought, look, we needed that project manager within the O&M space to manage that. There wasn't such an individual. And we thought, look, maybe it'll come from the commercial department. Those were thinking at the time. And then resources in terms of technicians. A lot of power electronics are going into the devices. This is new to us, and we thought, look, let's put into the structures that we need more technicians, senior technicians in that space, and a technician for performance monitoring. And again, a technical support manager in the cluster or operating unit, for example, Western Cape, the O&M project manager. We've got this 5-year O&M contract, but we needed someone to bring the bits and pieces. What bits and pieces, you may ask? The bits and pieces of the maintenance engineering requirements, the training, the aspects of the signal listing, the network management center, all those other good things needed to come together. And it was kind of hanging in the balance. So we thought, this project manager needs to be brought in to kind of bring in those bits and pieces. We had challenges with authorizations at the time. We needed that to be in place, particularly from HVREGs and LVREGs point of view. Portfolio of evidence, we needed to bring all the requirements in place for the contractor so that his portfolio of evidence is up to scratch and up to speed. Varying designs. Now, what was interesting here, we've got Highsong, for example, had slightly varying designs because at HEX, we've had one type of design, and then at Pongola and Ilanscope, a slightly different design. And you can appreciate the impact thereof on the cost of this non-standardization from an impact on a maintenance perspective, because now you need different maintenance documents to direct the maintenance on those so-called different equipment. And then you've got another contractor coming on board, for example, Pingawi, who's got containerized design. So, you've got the similar asset, but you've got different designs requiring different maintenance and operating. So these are some of the challenges, all right? My colleague spoke about augmentation, and I was a bit surprised that no one asked the question about who's going to foot the bill 5-year onwards. So role clarity, communication, those things are important. Data management, provision of historian. Naturally, a lot of data is going to come from all of this, all of these plans, and we needed, a domain for the data. Currently, we're using Maximo as our maintenance management system, so we needed to integrate that into the system. And again, construction quality, as in most projects, we need to ensure that there's a total quality management plan in place. And without the total quality management plan, you're going to have lots of snags that's coming in. And when you hand over such a project, I guess we all know this, hand over a project with a lot of snags, it impacts on the maintenance. Okay. From a governance point of view, again, we needed that role clarity from ourselves, or between ourselves, which is the Maintenance Centre of Excellence, versus the Western Cape or the operating units itself. What would they do? What would they, responsibilities and accountabilities? Who is going to do what and when? Will it be the Maintenance Centre of Excellence? Will it be the OU? Again, we needed that role clarity. From a documentation management point of view, when we got involved with HiSong, there was a suggestion that we establish a work group with HiSong, for example, to ensure that we start liaising with them to develop the maintenance requirements. So we established that little working group, and in our first few meetings, sometimes when you send an appointment out by MS Teams, the thing goes viral. We had something like 60 to 70 people in the initial meetings, and we can understand why, because everybody wants a piece of this pie and wants to understand how things are going, because it's new technology. But from a governance point of view and from a focus point of view, like Thomas had mentioned, we needed to keep focus. We needed to align ourselves and trying to keep focused to develop these maintenance requirements. And having 60 to 70 people in the Teams meeting became challenging. So we said, look, let's rethink this. If we had a work group with HiSong, and in a few years' time we have another work group with Pingawi, for example, it becomes a little bit challenging developing maintenance requirements, or different maintenance requirements with different suppliers. So we said, look, let's establish a K group within our SCOT structures. SCOT is an acronym that stands for Steering Committee of Technologies. And within Eskom distribution, we have this governance structure, and I show you from my experiences of working in the distribution environment, this distribution SCOT structure is very powerful, and it provides strategic oversight in terms of the governance, in terms of managing these technologies. So from a change management point of view, from a technology management point of view, SCOT, I believe, is world class. So that's just a little bit about that. So anyway, we established this BESS M&O care group within the SCOT structures, and that care group was basically to ensure that technology governance documents, data and processes were in place for obviously the effective management of this BESS. And it's the sole governance structure that has direct responsibility for promulgating and interpreting the O&M documentation. So the documentation I'm referring to is the standards, the task manuals, the training materials, and we'll touch on that just now. And this K group is operating under Thomas's study committee, the DC and Auxiliaries Study Committee. So then the work group leads at that time, we suggested that these work group leads liaise directly with these OEMs and develop the maintenance requirements with their in the respective spaces. For example, maintenance, the maintenance requirements, myself and my colleague Friki Konitsa would get involved, liaise directly with the contract and develop those things. From an operating point of view, Thomas Jacobs got involved. From the Networks Management Center, the plant management itself, we've had our colleague Nwabisa, who is liaising with them, and then from SCADA and Signals, Nwabisa as well. And then from a regional management center, this is now managing the resources, dispatching the energy, etc. We had an individual there. And training, we touched on, there was a question on training. So we had an individual to focus on training just to make sure all of those training requirements are in place. And then last, the actual contract itself, the contract, sorry. You've seen a few different departments therein. We needed that one individual to come and pull all these pieces together. I mentioned project manager earlier on in the O&M space, and we bounced back and forth between who this individual will be, which structure it would fit in. It was a bit of a challenge. So eventually we settled that the O&M, the OU, or the cluster contracts manager will take that role, and that was Nolan O'Case at the time. So the point is to clarify these roles up front so everybody understand what needs to be done, who is going to do it, and how they're going to do it. So those were some of the challenges there. You've been through the slide. My colleague Thomas shared that with you. But let's just touch on the operating, the boundaries of responsibilities. Now, when I say boundaries, these are boundaries from a physical point of view and from a system point of view. So everything on the left of that, as you can see, it's BESS, BESS 1 to in BESS, the contractor would be responsible for, and on the far right, on the right of that line, Eskom would be responsible for. Now, as much as I'm saying responsible, we clarified earlier on that Eskom owns the plant, okay? We are responsible and accountable for the entire plant. Now here, I've just expanded the view, and in red, you can see this is the entire BESS plant, right? My colleague Thomas has briefly explained the different components in the BESS plant. So the contractor is actually responsible for maintaining and operating that plant. And the black text on the top. So this is just the SED, the station electric diagram, that shows you, that gives you an overview of what the plant looks like. And on the top, the Eskom would be responsible. Now, I use the word responsible very loosely. Eskom owns the plant. Okay, from a legal point of view, Eskom is responsible and accountable for operating and maintaining it. So just to clarify that. Okay. So we had to develop the LV operating procedures. There's a document on the far right, and the contents of the document, basically, how to isolate the battery racks, and within the document itself, there's operating forms and instructions on how to do that. So it's how to isolate the battery rack and how to energize the battery rack. And the same with the PCS, the power conversion system. How to operate it, instruction forms are there, okay? How to isolate it and how to energize it. So we compiled a document sometime in March, published document, which now the contractor uses. So you might ask, why does the contractor have to abide by our internal documents? So it's a legal requirement. So remember, the scope of work document that I mentioned earlier on clarifies the roles in terms of the ops and maintenance. And in that document, it clearly says that the contractor needs to abide by the documentation of Eskom's. It's legal requirements. So therefore, we had to develop these internal documents that they would have to comply with. It's just a legal requirement. You might think, but they've done this overseas, they're operating it and maintaining it overseas, but why? It's just a legal requirement because we are accountable, okay? I hope that makes sense. So some of the lessons, and this is courtesy of my colleague down in the Western Cape, Tyrone de Villiers. He's given me his permission to share this. So what he's saying is, now you have to understand as well, Tyrone came in many, many months later from an operating perspective, and he actually developed that operating task manual. And unfortunately, a lot of strategic information wasn't shared at the lower levels, so sometimes you find a lot of questions coming down from the lower levels. We can understand that as well. So what he's saying is, it would make operating easier if the DC battery banks had a main isolator that would isolate all the strings from the inverter. Currently, each battery bank, which we have about 56 racks thereof, needs to be isolated to ensure no DC supply to the inverter. Okay, there's just one. Then the earthing equipment needed to earth the inverter is different from what we have. It basically needs a common earth clamp connected to multiple clamps to connect all the DC terminals, all right? And then in terms of growing our electrical grid, he says BESS is good, but it would be better if we had our solar panels. Now, I think that's in the pipeline. We did recommend to the business that some business case be done to add panels onto the system, okay? So that's what he's saying. It would be better if you had solar panels to charge the batteries instead of charging from the grid. So again, communication here, communication of strategic decisions to ground level was imperative. What he says further is that our control department uses SCADA that is limited to see and control only up to the ring main units, all right? Haisong has a different application that can control and see a lot more than our SCADA application. It would be great help if Eskom had the same application. So we are looking into that. We are looking into that. But from Tyrone's point of view, he says it really looks like the whole project was not planned well from the beginning. So again, he wasn't exposed to all the planning that was happening in the beginning. So you can understand where he's coming from. It's down to communication. It's communication down to the low level so that they understand what's been happening. All right? So he didn't really know. Okay? And I highlighted the whole point about communication. Okay, so from a maintenance requirements point of view, generally it takes us about 7 to 8 months to fully develop a maintenance engineering strategy or a maintenance standard. Now, we didn't have that time. And considering that Haisong already had the maintenance documentation, we said, look, let's work with them. Let's take their documentation and stabilize it. And therefore, I've highlighted that. So again, it's in the form of our ESCOM SCOT template, but we've taken their document and we've just stabilized it. So what you see is just a front cover with their document behind it, and that we published. And that covers basically the O&M plant, the services, it's, amongst other things, the maintenance standard, the monitoring and control system, the responsibilities in terms of the warranty, the classification and severity levels, waste disposal plan. They spent a lot of time going into safety, and we can understand that. Reporting in terms of corrective maintenance and a detailed scope of maintenance thereof. Spare parts, definition and maintenance, the spare parts listing, tooling list, future purpose of the spare parts. And I mentioned emergency safety incident response. I think Thomas has touched on that as well. And then training. So, yeah, training. And then there's annexes to that, the FMEA, the failure modes of the equipment and the analysis thereof. And obviously the maintenance activities that go with that. And I must applaud Haisong at this stage, because this FMEA document that they have done, wow, I was blown away by it. It's very, very comprehensive. It covers the nuts and bolts of every piece of equipment. Essentially, we are asking, what is the function of each component? How does a component fail? What are the effects of the failure? The consequences of each failure, and thereof, we determine the maintenance requirements, all the maintenance activities. So hats off to them. Now, the reason I'm putting this slide up is to say we've used Haisong's O&M manual as a, we published that document. Ideally, we would like to take 6-7 months and develop our own. So in some ways, I can't say that their document doesn't align to what we have. Essentially, it is there, but again, we're learning. We don't have all the information. But ideally, for all our asset classes, this is the approach that we would take, in developing our maintenance requirements. So you're probably familiar with all of what you see here, the entire maintenance management landscape. What's important here is that lower, the row right at the bottom, which forms the base or the crux of maintenance management. The first thing that's important there is the asset base. As you know, in maintaining any assets, it's important to have information on your asset base, information such as condition, the location of the assets, the health of the assets, and then the maintenance documentation. As I mentioned, maintenance documentation such as your maintenance requirements, your implementation standards, the strategy itself, the task manuals that tells you how to do the maintenance. All right, and then I'll touch on some of that just now, the job plans and all of those good things. Now, those maintenance documents give you a lot of information. It gives you a lot of maintenance activities. And with those maintenance activities come a lot of different people. There's a lot of different roles that different people would be playing. And for that, we need to ensure that those roles are clarified in the process flow, okay, and the organization structure. So that speaks of the organization structure and the resourcing. IT system, ESCOM distribution uses Maximo as our maintenance management system. So that's critical there as well. And then from a matrix point of view, we need to build performance management systems, KPIs, to make sure that the plant's performing well. And then the second level speaks of implementation and training, and it's about change managing what you see on the lower level. And if you don't effectively change manage what's on the lower level, then we'd have a problem. So that lower, the row right at the bottom is critical. So having those things in place doesn't mean much if you don't implement it. So that's why that second level is important. And then the third level is about planning the work, scheduling the work, and executing the work. And we have processes and systems that guides us how to do that. And the next level is the maintenance reporting, and that ties up with the matrix, okay? Maintenance assurance, we need to make sure that whoever's doing maintenance does it properly. So it's about going out doing ad hoc inspections, ad hoc assessments to ensure that the insurance is carried out effectively. And then asset health monitoring. We do that for all our assets to ensure that our assets are healthy. All right? So the whole triangle leads up to that, continued maintenance improvement. I hope that makes sense. Now, as I mentioned earlier, we took Haisong's document and we stabilized their document and published it. But ideally, the first thing we would do is develop a maintenance engineering standard or a strategy. And the crux of that standard is the FMECA analysis. Haisong has done it already. And that basically takes us to each of the components where we identify the function of each of the component, how it fails, what's the effects of the failure, and look at the criticality analysis, right? So essentially the maintenance engineering standard tells us what needs to be done and when. So it talks about the maintenance activities and the frequencies thereof. And then after that, we would develop a maintenance implementation standard which follows from the engineering standard. And the implementation standard is more of an execution. It details the entire execution of what needs to go in. So it talks about the asset base, as you've seen, the maximal configuration, the metrics, the work planning, the work execution, reporting, assurance, and asset health monitoring. So it goes into detail for each of those sections, all right? And then the task manual is critical here as well. And this becomes the legal document. And therefore, I mentioned earlier on that Haisong needed to work in terms of Eskom's SCOT templates. The task manual details how one would go out and effect maintenance, and how is critical. Attached to the task manual are the inspection sheets. Those are the different checks that one would do in the various components of the plant. Okay? And then we would also develop the job plans, and the job plan just basically gives you operational steps as to what to do. For example, it's just a few steps. One would say, one step might be to say, ensure that your health and safety aspects are considered, ensure that environmental aspects are considered, ensure that you've got proper PPE, and then perform or do routine inspections as per task manual. So that's a small document, but it refers to a task manual that goes into all the details, and as you can see that. So these are the maintenance requirements, very, very high level, and that's the legacy approach that we would use for all our asset classes. Okay. So, yeah, so this is the task manual that we have developed. It's still in draft, as you can see. It covers the roles and responsibilities, safety and risk assessments, and the inspections. Now, you'd see daily, weekly, monthly, 6 monthly, annual, 2 yearly, 4, 5, and 10 yearly. Traditionally, we wouldn't go into so much in detail, but this is now guided by Haisong. And basically, that's covering the various components that my colleague Thomas had actually shared, right? The battery racks, ACC and DCC panels, PCS, inverter transformers, the auxiliary transformers, the ring menus, and the DC cables. So attached to this are these inspection sheets, which I assure you is very, very detailed. So we are still working with this, trying to get it going. I can't go into the details of the challenges, there's just too many, but hopefully we will have this task manual with the inspection sheets published very soon. Now, my colleague touched on augmentation, and as I mentioned earlier on, I was surprised that there were no questions around the cost of this. You need to know that the cost, well, in this case, in our case, the cost had to be or will be bared by the operating unit. So one might ask, how do you balance this CAPEX to OPEX? Unfortunately, the operating unit is going to cover the cost for this. But I think it needs to be communicated up front who is going to foot the bill for this. So just keep that in mind. And that's one of the lessons to learn there. I hope I'm not going too fast. Is everyone with me? Yeah. Good. So, BESS O&M management, project management. I mentioned earlier that we needed an individual, be it in the form of a contracts manager or a project manager, to bring all the pieces together. And that was still floating in the organization some because we just didn't have this individual. So I was tasked to lead this for a few months to get it going. So, and that's what I did from February or so. And the whole idea was just to kind of establish a committee or establish a team that oversees the management of the O&M such that all the pieces are brought together and that the plant is operating and being maintained as per plan. And I thought I'll just put a quick snapshot of the agendas and some of the action items that we would follow through on. So a lot of work went into that. I think it's still continuing. It's been handed over to the operating unit contracts manager to follow through on. So that's ongoing. So on a daily basis, we get a report from Haisong Monitoring Center. That's the HMC, and that's the monitoring center at Megawatt Park. On a daily basis, we get this report, and essentially what it's saying is it's giving you the state of charge of the batteries, state of discharge of the batteries at the different times. Okay? And on a monthly basis, we get a more detailed report that gives you the lessons, or the challenges, or the failures, and those type of things. Okay. Lessons learned. I did speak about the role clarity. We did have challenges there, and it's important that these things be pointed out up front. Who does what? When did they do it? When did and when? I mentioned that this project wasn't business as usual. It's not like we build a substation, you hand it over to the cluster, the operating unit, and you run with it. No, it's not business as usual because distribution has now entered into the so-called generation space. Well, we're not generating here, but if you can imagine, you've got PV on here with SSEGs and microgrids that's coming on board. Distribution business has entered the generation space, so it's not business as usual. And we needed a home to manage this O&M aspect of BESS, okay, for the first 5 years at least. One would know, structure. Structure follows strategy. So when you develop a strategy, in the strategy itself, you'll develop and ascertain what the structure is. So the importance of strategy integrating BESS O&M management into existing structures is important, so you might want to take note of that. Okay, and we're still trying to find our feet with that there. Challenges with the BESS training from a change management perspective, change control management, we're still grappling with the training materials, the operating and maintenance itself, we're getting there. But just take note of that. The whole change management is important. Communicate, workshop, get everybody on board this journey. We talk about a shared vision when we develop a strategy. Every level of the organization should share in that vision. All right. Up until a month or two ago, we still had a project snag list. The project was actually handed over sometime in December. It's been operational for about 8 months or so. But from a project point of view, there's still issues from a quality management perspective. So those things we need to still deal with. That's the last of my slides. Thank you.
Thank you very much, Engineer Prasad. I think the key takeaways from here, and jumping from Engineer Jacob's statement, is that you must just start. And I think also key is that you must fail quick. The sooner you fail, the sooner you learn. And that's the only way you can learn. If you're not failing, you're not learning.
Correct.
All right, so much for that. I don't know if there's any questions in the crowd.
This one.
From this side this time. Yes, ma'am.
Thank you so much. I just have 2 questions around change management and also around stakeholder management, because I didn't hear that coming through. And let me start with that one around the communities around where the project is. Was there a concerted effort to actually get them involved? Obviously from SDN, I would imagine you would have, but I'm not getting the sense that there was buy-in from the community, even when you were placing contracts with them in terms of SDN. So I just wanted to elaborate in terms of lessons learned, just what happened there. And then on the change management, I'm also not getting, or maybe just explain further, was that incorporated from the beginning of the project when you were looking at the strategy? Or you just looked at training as only change? What about behavioral change? Did people, like for example, the snag list you spoke about now, could it be that if you were to do the root cause analysis, people didn't really buy in some of the things, they were not, you didn't have like sort of proper OE, organization effectiveness interventions to get people to, just to check also, change readiness and all those things.
Thank you. Valid questions. So I'll deal with the first one. With regard to SDNL, I know in the other projects we had our SDL department that we're engaging with the communities. We had extensive engagement with the communities, and I'm pretty sure the same would have happened with HEX as well. So that has been sorted. From a change management perspective, I think there are lessons to be learned there. Maybe some gaps in the sense that it wasn't as effectively change management as we would have liked to. For example, the role clarity, the communications, the workshops with every level in the organizations to say, look, this is our vision. We need to share that vision with you. These are the expectations from the different departments. This is what your role is going to be, when, how, what, etc. That could have been done better. So, point taken. Thank you.
Yes, sir.
All right. You touched on this, the O&M costs that will be bear by the operating units. But you haven't touched on the impact that
that this BESS project has on the O&M cost, and how are the operational units going to recover those costs?
I had a feeling that question was going to come out. Really. And I was going to suggest that a business case be done at least to ascertain what those costs are going to be. Thomas, I don't think we've done that as yet, right?
So there are teams, like a pricing team, there are teams looking at the costs. At this stage, we don't know what it is yet. We make provision for it in the budget. But we will, it's been looked at. So there is a business case. Obviously, when you do a project of this size, there should be a business case for the management to make a decision, do we go ahead or don't. And there's other factors. It's normally, sometimes it's not a, let me put it this way, there's also other factors that, strategic decisions that our management needs to make to decide if projects go ahead or not. Okay.
Thank you.
Why I'm asking this question is because you are going to roll out these projects, and that's how ESCOM does business. You have a prototype, you roll it out before you ascertain how much it will cost and you recover those costs.
So I think watch the space. All right. I hope that answers it, but yeah.
I think there
was
last
another one.
Two hands, 1, 2. Yes, sir.
There's one question from my side. You mentioned quite a number of inspections that need to be done. And my assumption would be that these are some advanced pieces of equipment. You actually need all those inspections and what they are doing and waiting for process.
No. So there are inspections that you would say daily, which would be done remotely, okay, via SCADA. You got to be practical. You can't be doing all those inspections on a daily, weekly basis, or even a monthly basis. So it's broken into different categories. There are certain pieces of equipment that will be inspected 6 monthly, annually, 5, 10 yearly, etc. All right, and certain equipment that needs more frequent inspections. So those things are informed by this FMEA analysis that I mentioned. Okay, you look at the failure of each component, how it fails, what are the effects of the failure. The analysis is done on that, which then determines the maintenance activity. In other words, the inspections and the maintenance thereof. So it's well informed by the whole analysis of the failure modes, etc. I hope that answers your question.
Thank you for the presentation. I have thousands of questions.
You can't have all 1,000.
So as part of PV plans O&M, I think there is some kind of a requirement to decommission the plants and test them in the labs to check their reliability. So is there a requirement, or how do you ensure the reliability of the battery modules after some time? I mean, they lose capacity over time, and the previous speaker mentioned that after 5 years, they decommission one stream and they
Augmentation.
and then they put on the other systems to create a space for other new battery modules. Now, my concern is because they have experienced that other modules have been discharged to 0%, and so I'm having a feeling that there will be different state of health of the battery modules. Now, you can't just take one battery and connect it to another stream because it might cause issues. So with that regard, I think there will be the need to actually test these battery modules before you can decommission them and put them in another system. Is there that kind of procedure in your O&M? And another question is, what IEC standard do you use that governs the BESS O&M? And as the last question is, what is the O&M contractor selection criteria? I guess you advertise the tender and they apply, and what is the selection criteria? Because I would like to publicity.
Sure.
Yeah, and on that again, I would like to think that BESS is actually a new field, and actually the public now is getting this field. And what is your contribution towards developing the skill of the country, especially to the young scientists and young engineers who would like to be in this field?
So I like your questions.
You know, you could have started with that question.
You should stand beside me and we'll address everyone and say what you're capable of, and then somebody will employ you. Valid questions, good questions, and I suppose that's one of the strategies of having these kind of technologies being implemented in the country. It creates those opportunities. Okay? The last one, was that a comment or a question? I think there were 4 questions.
The last one was about the job.
If I had to address one of your questions about the augmentation, so interesting point, and I guess it's we've got 5 years to do that, and you're welcome to come and chat with us and help us to put that process together. Okay. The other question was around
Testing before decommissioning or something.
my colleague Thomas is going to.
So what would happen is, when you move those racks from bank 6 where they are at the moment and put it with others, you need to balance the cells. So that's an important thing of this site, is because there's thousands of cells on the facility, and all of them must be balanced within certain parameters to make sure that when it discharges, all the cells discharge at the same time. Because the battery management system monitors the rack, all the cells in that specific cabinet, and if any one of them goes outside the safe limit, it shuts down the whole rack. So that's why you can see that everything must be in sync. So that's a key thing that they're going to do when they put it on the other side to make sure that happens. The incident I mentioned about the over discharge, it shows you how important the battery management system is, because although the voltage went lower than what the PCS could see, the battery management system still protected the cabinet to make sure that it doesn't go outside the safe limit. So it doesn't affect the health of the bank.
Thank you very much. Oh, let's park it there. I think this is a good opportunity to allow for engagement during tea time, which we're going to have now. Please, let's take a tea break, 10-minute tea break. Remember, it's not about what you know, it's about what you know and who you know. So let's interact and bounce off ideas. Please, ladies and gentlemen, let's make sure your name's on the register for CPD points, and let's have tea and engage. See you in 10 minutes. Thank you.
It's a good learning curve.
God, the fact that I'm looking at the YouTube and people are saying, we cannot see the screen, we cannot see the screen. So the first presentation Yeah, no, I'm good. I was just, I didn't know what the password was. I was phoning the prof and then I realized you just press enter and it works. I was going to say to you, we missed, just before, when we break for lunch, all the speakers must just stay behind. I just want a picture with everybody. I don't want, I didn't want to do the masses yeah, as well. But I don't know what time it's like. When we break for lunch, we can go out. The speakers must be near. So it's better, so it's better photograph. I want photograph. What's the name of your... And the date? Hi, Prof, sorry. I know, I'm okay. I was trying to get the password for the laptop, but I found it. I got it. Thank you, thanks.
All right, welcome back from the tea break. I hope you enjoyed your tea break and you interacted and exchanged details there. We are on to the second pot of the three-pot system. Done with the first pot, now we are on the two pots left, with lunch in between the two pots. Anyway, so please once again make sure your name is on the register with your email address for the presentations to be shared amongst for all the delegates, and for CPD points your extra registration number is on the list there. You might notice that I refer to all the speakers here as engineer, and it's very important that we do that because we need to put identity to ourselves as engineers. And I'm glad Engineer Mjali is in the room from EXA. We're trying to put a motion through that we get that prefix approved, that we can be called engineers like doctor and advocates. You know what I mean? We are equally as important, right? So yes, comrades, let's push for that prefix. It's very important. All right. Our next speaker. Just checking. Everybody good? Thumbs up. We good? Sorry, Teams has messed up with my mind. Thumbs up. Thumbs up. Thumbs up. Thumbs up. Thumbs up. You're good. All right. Our next speaker on insights from the original equipment manufacturer from Hyungsung, Lefika Makita. Just a brief bio of Lefika, Engineer Makita. Or Lefa, not Lefika, my bad. Lefa Makita, Engineer Makita. Lefa is a qualified professional engineering technician with over a decade of postgraduate experience in the energy sector. He has worked with leading organizations such as Eskom SOC, Siemens, and SGB Smith Power Matla, gaining extensive expertise in technical and sales functions. Currently serving as a technical sales manager at Hyungsung Heavy Industries Corporation, South Africa, Lefa is dedicated to delivering exceptional customer satisfaction through innovative solutions in energy storage systems, transformers, substation equipment, and higher voltage products. With a deep understanding of the Southern African energy landscape, Lefa excels in identifying customer requirements and providing effective solutions. His excellent time management abilities and strategic approach to sales have consistently resulted in high levels of client satisfaction and business growth. Ladies and gentlemen, please welcome Engineer Makitla.
Good morning, ladies and gentlemen. I will say to the director that the name Lifika I do accept. I've tried to shorten my name to Lefa because of my birth. Actually, my full name is Mujale Falamang Wagamakitla. So it's going to be a little bit challenging for you to be able to. All right. It gives me an honor to be presenting on behalf of Haisong Heavy Industries in relation to the subject matter for today. Decided to take in a different approach actually when I was sitting down in terms of how I will be delivering in the presentation today. Ladies and gentlemen, energy security needs pragmatic policy for us to be able to reach in the objective that we want to reach in this matter. What I would like to do is that I will not be doing justice to the audience by not introducing Husong to the greater population at large. So I'm from Husong Heavy Industries. It is a division of Husong Corporation. Under Husong Corporation, we've got a lot of companies. One being the Husong TNC, which deals with textile. Husong Advanced Materials, we've got two of them, deals with the tire cords and then also industrial materials. We've got Husong Chemicals, which also do new materials, and then also the TNS, which do the ATMs. As a matter of fact, in South Africa, your majority banks, they buy ATMs that we are using from us. We are actually the innovators in terms of bringing in the ATMs that you just have to tap in your card, you don't have to insert it. So we are the pioneers in that. So where do I fall? I fall under the red square, which is the Husong Heavy Industries. And then under Husong Heavy Industries, just as a brief introduction, I've also got a colleague of mine, Mr. Victor Kuboni, with the audience. So he's the specialist when it comes to transformers, GIS.com, HVDC, and then also some elements of the microgrids. I'm with the BESS section. In the African market, I will say that BESS, it's still in its infancy. From Husong side, we have started to develop BESS since from 2009. Our very first order that we have delivered into the market, this was from the CAPCO. CAPCO, it's a utility, same as ESCOM, but from the South Korean side. So that is where we developed in our first project that we have delivered already in 2009. Fast forward to 2022, that's when we started with the ESCOM project. Now, in terms of just giving an overview of some of the applications, just to clarify some of the items that I've heard from some of the questions that were posed. So it can do multiple functions. One, it will be the renewable integration, the peak shifting, multifunctions of grid, and then frequency regulations. Otherwise, others, they will identify it as ancillary services and support. So we do have experience in all the aspects. Now, to the BESS insight. So what we have given to ESCOM, we started with the engineering. Under engineering, what we have done is that we have done the configurations for the BESS. This will start from your PCS, your batteries, and then also your balance of plant. We've done the electric designs, construction designs, the battery sizing of the whole project, and then also site arrangement optimization. Because of these things, they've got a limitation or where they need to fit on the site itself. When it comes to the manufacturing, procurement, and transportation, we're also responsible for it. So we have sourced out some of the materials, obviously, from other OEMs, but it's something that we'll delve more into as the slides continues. And then we have done in the construction where it was an EPC rep, including civil works and then also installation and site testing. And for 5 years, we are also still engaged in this marriage with ESCOM. And then the baby that maybe we made from that 5 years is the O&M. So that is where we'll be doing the performance guarantee. All right. So let me break it down. It's not the first time you've seen this map. The experts before me, because I'm an industry captain, they are the expert. At the end of this presentation, they will be taking some of the questions. But just to try to summarize, we've got 3 sites which have been allocated to us, the Pongola being the 40 megawatt, 160 megawatt. We've got the Elandscope also in the KZN area. And then the one in discussion here, it is the HEX, which is the 20 MVA, 100 megawatt hour. So this falls part of what we will call phase 1 from ESCOM that is funded by the World Bank Group. Out of that, 6 sites have been awarded, 3 to our competitors and then 3 to us. And then there are still 2 more sites. The Malkot one, I think it is around the Kruger area, and then the Rietfontein one that is closer to the border of Namibia. Those 2 are still under adjudication stage. So this is just only a picture of the aerial view of where we are. The first one, it is the Pongola one. I think it is 2 times the size of what we have in HEX. And then this one here that it's not showing here, but the one where you see mostly on the clay soil, that is the HEX project. And then you've got the Elandscope one, and then also the monitoring center, which is situated at ESCOM Megawatt Park. So I'll also go into the concept of the monitoring center, but basically what it does, it monitors the 3 sites with the capacity to still integrate more than 8 sites in the same setup. So ESCOM colleagues, be assured that for all other projects that are still coming, the system is already in existence. Okay. When we were having lots of discussions with the industry experts, they described this project as one of the best projects that is above market standard. I'm just an engineer from my side with an ambition on the business management. I will concur with their feelings. Ladies and gentlemen, let me just take you through the BESS overview. The award date of the contract bid was May 2022. The site was handed over officially to us August 2022. And then the construction started in November 2022 with mechanical completion of August 2023 and operational completion by December 2023. That's when we handed over for operation and maintenance, where the 5-year period started to kick in. Now, I just want to give in statistics also in clarification to one of the questions that were posed to the previous speaker regarding the involvement of the community. So with this project, there were 250 local people that were employed during the construction phase of the time. At the peak on site, we had about 293 people. Obviously, because of it's a specialized solution, it will include experts from the whole parts of the world, as a part of delivering this project. There were a total of 72 SAIEE audits that were conducted. We from HUSO, we scored above 98% in all of them. 14,000 kilometers of cable was installed for the project. And then I will touch base on the new trends that are happening to the market in relation to this kind of length of kilometers for the cable. Also, we have installed 12,000 cubic meters of concrete. One or maybe some of the reasons why we've installed that, it is because of the soil where HEX is situated. It's an organic soil, so you cannot do much compacting with that kind of a soil. It's not too stable for that intended purpose. Now, as I move on to the next slide, I would also like to highlight in terms of our scope. This was the new HEX site that we have done. This is the BESS area. Part of our scope included 2 sets, additional expansion of the MV switchgear. There was 2 times 10 MVA transformers, which we needed to replace with 2 sets of 20 MVA transformers. And then also there was some work that we have done on the existing HEX station in the form of oil dams that we needed to make the increase thereof. Now, in terms of the total progress, as of 30 November, we've already completed all the activities. The only thing that we're still engaged and finalizing, it was the retake testing so that it is grade compliance and it's allowed. So this slide here, it was shown previously, but just to give an overview in terms of, this is a system. It's not just one particular product that we use on it. It's a complete system. So it will include in the batteries, which are lithium iron oxide, obviously in terms of the technology, and then the manufacturer in this, it was the Chinese, which is the CATL. We had the PCS, which was a bidirectional PCS from our PE, and then we had EMS. We've got inverter transformers, power transformers. This will be the 20 MVA transformers, 2 of them, and then we had the auxiliary transformers that we supplied. This is just an overview of the HEX site. And then also this slide is something that you have seen all the experts. They've made an explanation in terms of what is happening there from our side. I think what we need to also highlight is the security that ESCOM required. As you are able to see that this is a 3-tier fence that ESCOM required. We've got both thermal cameras and then also like your normal cameras just to monitor in terms of the system. So hence I say that I concur with what the specialists have described the project to be. Now let's take it to the O&M concept. I've shown the picture of the operation or the monitoring center at ESCOM Megawatt Park. Yes, it is a facility that obviously was built by Hillsong, but it was built on behalf of ESCOM. ESCOM will be operating this system going forward. So it is part of the skill transfer that is happening, and in terms of the training that, because of to us as Hillsong, it is no longer a baby, actually it is now a teenage years. With ESCOM, they still have to nurture and then learn the skill on how to do it. One of the challenges that the previous speaker mentioned was that ESCOM used the SCADA system, and then the system that we're using from our side, like it's comprehensive and can show all different functions. So this slide is just one that gives an overview of how we do it, and then we are here to also support ESCOM to find in solutions that will be able, that the system that they are currently having is able to integrate with the system that we have built for them as part of the skill transfer. Now, one of the items that I've mentioned in the presentation was the sizing of the batteries. So the most important one here, it will be the augmentation simulation based on our simulation and then based on the consensus that we have reached with ESCOM, or rather our proposal is that we will do it every 5 years. The reason why I'm touching on this topic once more, it's very fascinating to me. Unlike with the system itself, where we've got experience, when it comes to the concept augmentation, no manufacturer in the world has done that, at least as of yesterday. My hope is that ESCOM will be the first in the next coming 5 years. So it is something that, with this marriage, we'll have to handle it together and then develop stronger in relation to that. So now, when it comes to the bank, I think they've, when it comes to the bank, they've explained the concept of how we want to do it. So this is still a concept. It has not been done anywhere else in the world. You can go to any manufacturer, maybe one of the biggest in the world, and our competitor being Tesla. I mean, they've got lots of gigawatts that they've installed worldwide, but none. So we are hoping that maybe next year, if we come back to this seminar, we'll have a different story to tell in relation to the augmentation, but it's mostly an important aspect. And then this slide also here, what it shows is that in the red there, BOL, so this is the installed batteries currently, what is happening, and then the new one will be represented by the blue color. And then in terms of the relocation, Mr. Thomas has alluded to the fact that obviously as time goes on, you know, this battery, they degrade. And then you can't mix new batteries with the batteries that have already aged and degraded. So hence we have developed this concept. So this is the same slide in terms of how are we going to do it based on a one rack movement. We are explaining it here in detail, but they've already touched on it as the expert matters in this. What I'm showing here, you know, they always say that pictures give in a different perspective to the presentation and then to a whole understanding. This is when we started with the project. The pictures in terms of the kind of exercise that we were involved in, doing in the battery installation and then also building all the platforms. On the next slide also, this is the platforms from an aerial point of view. And I would like to highlight one or 2 points on this pictures of the transformers. And then the reason why I would like to highlight that, it is precisely for this. When we were doing the execution of the work, this was majority during load 4, load shedding, stage 5, stage 6 load shedding. So with the support of ESCOM, we have had to find in, and then also to be specific, the project management initiatives from ESCOM. We have had to find in innovative ways on not to load shed the customers more than already they were suffering at the time. So ESCOM have what we will call the mobile transformers. So we took a 20 MVA mobile transformer from ESCOM to connect in the load that was coming from the 10 MVAs that we wanted to change, so that we save on time of the execution of the project. So in total, with that innovative idea, what we have done is that we saved 7 months in construction period by that method, so that we do not load shed more customers to already what they were suffering at the time. I'm glad that load shedding is an issue of the past now, ladies and gentlemen. All right. So this is just also the progress of what was happening on site. And then the last picture, this is the baby that came out of the marriage that I just spoke about, the hex site. Ladies and gentlemen, this, in my opinion, as Mujale Falamang Wakamakitla, it's a technology that ESCOM preferred. It is changing now in terms of the, oh, my slides have moved. Chair, you want to help me on how to move? While he's still assisting with that, this technology, it is something that was procured already in 2022. Now I want to give an insight into the technology trend now as we are sitting here today. The first one on the battery side, what was happening that it was into the building type. I will call it the first generation of the battery system. Please do not call it that. I'm saying it for lack of better word. And then the second one was the 40-feet container type. The reason why we've got there was a 40-feet container type, it was because of the fire issues that were experienced. And then one of the clarifications or the questions that were posed was that how do you take care of that effect of the fire? So because of the learnings of the past when we started with this technology, we identified that maybe it was not the best solution into the market at the time. And then we moved on to the 40-feet containers. Also, battery manufacturers, they are located in China, mostly. Almost everyone else in the world buy from China. Now, if you were to transport in a 40-feet transformer, a 40-feet container to all parts of the world from China, the logistics there is going to cost a whole lot of money just to deliver this kind of product. So we came with another approach to do in what we have now at HEX. The HEX one, this is the modular type, which is able to be transported everywhere else in the world. So as I was saying, that this was in 2022. Now, fast forward to today, as a matter of fact, there is a solution for a containerized system. Now, on the containerized system, we have increased in the energy density of it, as you can see, from about 372 kilowatt to now being 5 megawatt. So it's a huge improvement. And then it also have all the safety aspects in relation to it. And then this is just only a trend just to show in terms of the degradation of the cells. The first simulation that we have done, this was with the LG batteries, and then the second one, it is just showing what we are using for CATL. The red will represent in the 1 cycle, and then also for 2 cycles it will be represented by 10. For Eskom it's 1 cycle, hence it's able to still be able to produce in the contracted capacity. This is just a graph representation of what I've just shared previously. And then I want to come to the PCS. Central type was the first generation. In the amount of cables that goes into it, and also optimize the available space area that you have for the site. Now, going forward, and then this is what that the R&D has advised, that what you're seeing here, the number 4, this will be the technology for the immediate future, where your PCS it also forms part of the 20 feet container. So that also further gives you the option, to optimize your designs and then get this minimum BOP work for this project. So it is a bit of saving now to the customers and then the end user of this product, in this case being Eskom. So this is what we have on the top here. Mr. Thomas has went through it, what we currently have. In the future, this is what we will have. And also in the near future also, this will be removed. Obviously the PCS, transformer and RMU, they're gonna form part of the 20 feet container. So this is a technology that is still in development, but at a very, very matured time. So the augmentation of it, this is how we be carrying out the augmentation for HEX. But for these new technologies now, it is quite totally different. When you develop in the site, you leave this area for first and second augmentation if you need the third augmentation, and then this is how you're going to. So you will not be now moving the racks and then slotting it on the modules that you have. In this case, this is the containerized solution. In conclusion, I would like to clarify the point that was asked by one of the audience members in relation to the issue of the local communities. My advice is that you cannot afford not to communicate with the locals when you're handling a project of this magnitude. HEX is the best case scenario because of the geographical location of where it's seated, but proactively with the support of ESCOM and other community stakeholders, we were able to deliver this project successfully and then on time, including on budget. When you move further away from the Western Cape and then you're starting to come inland to also the coastal on the eastern side, being your KwaZulu-Natal, it's a complete different ball game altogether. This is where we've got Pongola and then we've got HEX. So you can imagine that the challenges now are different. So South Africa is a very diverse nation. We need to embrace that. Now, these discussions and negotiations, they are, you've got to make sure that they are practical to wherever you are developing this. Traditionally, African people, they are from an era where you need to have a face-to-face discussions with the people. So in the case of Elandscope and Pongola, you still have to go and then have the engagements with the local chiefs, local kings in relation to the projects that are happening. So those are just some of the dynamics that are very much important that you discuss and you engage proactively with the community if you've got a project of this magnitude. Otherwise, we are not able to quantify the stoppages that you'll have on site, and then those will delay in the project. Ladies and gentlemen, I would like to thank you for giving me an opportunity to give in my presentation in terms of the insight for this project. Thank you.
Thank you very much, Engineer Mojalefa Lahamakita.
Thank you, sir. Thank you, sir.
And I'm glad you ended on that note because on the culture or all the consultation of the communities, because as engineers, as we discharge our duties as engineers, we need to conform to the EXA standard and EXA rules of conduct. And one of them, when you get registered, is outcome number 6, which talks about recognizing and addressing reasonable, foreseeable, social, cultural, and environmental effects of the jobs that we do. That's very important. And all the guys that are potential EXA registered engineers, please, you need to make note and be aware of all these conducts and outcomes that you need to conform to. But thank you very much. Before you take questions, you mentioned about how augmentation has never been done anyway before, and you'll be the first one to do it. I think you will know that South Africans, we like challenges, right? I mean, Thomas, I'm looking at you right now. We like challenges. How do they say it? Ele weet nie wat ons weet nie. They don't know what we know, so rest assured we will execute it successfully.
Absolutely, absolutely.
Ladies and gentlemen, because of time, I will just take 2 questions before we move to our next speaker. You are barred from asking questions. No, I'm kidding. Let's just first see. Okay. Yes, sir.
Yeah, with respect to we have investigated globally, and I don't know, is there any cases of in relation to outcome number 6 with respect to the impact of this BESS to the environment, to the soil, to the people that work with this kind of chemicals. We spoke about lithium. I'm not also sure if, like in the South African environment, how agile are these products when you are up in here, and now you are in Johannesburg, you are in complete different environments, you understand, with the extent of heat, the extent of heat. How are those contributing to the lifespan? You understand? Thank you.
All right, we'll like to take another question. Okay, maybe let me give feedback in terms of the very first question that you've asked. Mr. Mondi, when he started his speech, or presentation rather, he mentioned about the JET program, Just Energy Transition. Now, part of the Just Energy Transition, and then I'm going to focus on the Just part. Just part is about looking at currently the socio-economic of the activities in the area where you'll be having the stations. Now I'm going to just make an example just to try to clarify your question. When you look at the geographical location of, let's take Komati, for example. It's in Mpumalanga, traditionally coal area. Obviously, there are a lot of trucks that are transporting a lot of coal, and then obviously the local community, you know, through that partnership, that is their livelihood. Now, on the just part of it, with the battery energy storage, is that we are integrating the community into energy, the new energy mix. That, you know, you don't have to suffer a whole lot of things like your. Just to give you an example on the energy mix, things like your frequency regulation and your load shedding and all of that, because of taking into consideration that traditionally electricity used to come from the north going towards the south, but now with lots of renewables that are coming, it's going to come from the west, or rather the south, going to the north. So those are the challenges and opportunities which all of us here in this room, and then those who are joining, you know, visually, to be able to answer those questions. Now, in terms of the safety aspects, coming to your question two, in terms of the safety aspect, the kind of technology that is being used, it actually strives better on the hot conditions. So it was designed specifically for the African and then Asian market. So you will not have any challenges in relation to that. This technology was developed from the fire challenges that they had in areas where, you know, the BESS market has been ripe, in the UK, in the Korean market, in the US market. So I hope I've brought in clarity to your question.
Thank you, thank you. Okay, can I take one, and then I'll decide afterwards?
Very quick, thank you. On the block from the Energy Council of South Africa. What would it take for OEMs such as Hyosung to manufacture locally?
It is a thank you for the question. And when I think I spoke to you outside, I knew that that is the question you wanted to ask. Let me try to answer it this way. Let me try to answer it this way. There are plans in the process, obviously, to have this kind of products to be developed. So we are still at the initial studies, because there are multiple factors that we need to look at, you know, things like will it be competitive, like in the South African market or in the global market, things like your electricity price and the whole supply chain. But it's something in the works. And then I think in terms of giving in a more clarified feedback, it is something that I think in the next year we will have a clear plan in terms of how we're going to tackle it. Thank you.
Thank you very much. Can I ask the two questions to be taken offline, please? Thank you very much. I'm just watching time now. All right. Thank you very much, Mojali Falaha Magida. Oh, yes. Okay. Good. Thank you very much, ladies and gentlemen. Our next presenter on, I think it's two presenters. I see two names here. On environmental authorization and land and rights aspect, Owen Peters and Namhla Dondi. Owen Peters is a seasoned land and rights practitioner with extensive experience spanning over 2 decades in town and regional planning, land acquisition and environmental management, holding a B Honours in Spatial Planning from the University of the Free State. In his role as a manager of land and rights at ESCOM, Owen led a team responsible for strategic land acquisition, budget development and project execution. His career highlights include managing and land development, inputs for capital investment programs, ensuring legal compliance and maintaining financial sustainability in land use projects. Ladies and gentlemen, please welcome Owen Peters.
Good morning, everyone. I'm the first presenter this morning that's been introduced as not an engineer. So thank you for that. Breaking away from the norm. And I will be presenting on the land acquisition that we required for the battery energy storage systems at the Hex substation. So the contents of my presentation will be as follows. I will cover the objective, the site background, the land acquisition challenges that we faced, and how we resolved them, and what lessons we learned from this, and then we will conclude. So the objective is understanding the critical of verifying ownership and cadastral data using the Hex BESS as a case study. So importance of when you own a piece of property or you own a house, do you know where's the boundaries between yourself and your neighbor? Often you have fights between neighbors because they say, this is my fence. You can't hang your washing here because my property runs here. And this is a similar case we had where we had to define what is the boundary between ourselves and our adjoining neighbor. So the site locality, you're all familiar with the site is in the Western Cape. It is an old coal power station substation site back in the 1950s, around until the 1988s. It's an industrial area. It used to have some nice facilities there as well. You can still see if you go to the site, some sport and recreation facilities. A clubhouse apparently where we serve some of the best beverages we could have tasted at the time. And we also had accommodation for staff. And some of those facilities are still there. So if you go to site, you'll see the buildings that's there. It's still the old buildings kept in the same manner and way and facades of what it was back in the 1950s up until the 80s. So, when you go to site, what do you see? Now this is a cover from Time magazine at the end of 2019. When they predicted what's going to take place, what will be the major things. Time magazine said these will be the major things happening in 2020. Can you spot what those things are? Trump, Brexit, yes. Anything else? AI, yes, AI, correct. Anyone see Tokyo there, perhaps? Yeah, the Olympics of 2020. You see the Mars. But what don't we see there? Come on. Okay, maybe that's correct. Yes. No one foresaw that COVID will take place in 2020. There was nowhere in the 2020 vision. And I draw parallel to that. It's exactly the same what we saw when we came to site. We thought it was a site owned by ESCOM. But when we got there, what did we see? And I'm sorry to use, excuse the pun, my environmental colleague, that to use wood and forest to explain what we saw. The two just don't go hand in hand. But we saw that there was well, initially when we visited the site, it was all an open piece of land. You could drive through, you can walk through, and it was a free-for-all. And then we visited there in COVID, actually after COVID, and all of a sudden, there's now an electrified fence, there's a motor, there's higher security, and we're asking ourselves, but who erected this fence? And who gave the person permission to put up this fence so that access is restricted? And it's through those questions that we discovered and a lot of things unraveled and unfolded. So what we saw, and this is now from a survey perspective, a national perspective, is that in 2003, so that's 21 years ago, there were about 5 or 6 different portions of property. And they were subdivided into these various portions. And when you have on the eastern side this long strip of land that was supposed to be subdivided into 3 portions, and they have got unregistered urban. So diagrams for this urban were created, but they were approved at the Surveyor General's office, but they were never registered in the deeds office. So never annexed to a title deed of a property. And the intention was, and you can see the hex site, we're in the middle, so to speak. That was the substation site, existing substation site, to be consolidated with the portion of land next to it, and for the intention for hex then to be on to the northern side. Then we also discovered that, and that was the consolidation I referred to, that the third portion at the bottom, there was some understanding, some agreement with the landowners at the time, and it was the previous landowners or the current landowner's father, where Eskom was going to transfer a portion of land to this owner as part of a sale agreement. And that registration also never took place. So we did all of that information or those fact findings by using the following tools. So it's Cape Farm Mapper, the Chief Surveyor General's Office, Riskcape, the Cape Consumer Profile Bureau, the Cape Town Deeds Office, our Small World software program, as well as information from the municipality. Using those tools, this is what we saw. Furthermore, so we see on the one website, this is our Cape Farm Mapper, it's a Western Cape software, GIS tool, that for both the hex site we're in the middle and the site just at the bottom, they both have the same earth numbers. Then, if you go to the next Chief Surveyor General's website, you see that they reflect as different earth numbers, but the earth number on the left-hand side is earth 16127. Now, if you search for earth 16127, it gives you a site highlighted in orange, and it tells you that earth 16127 is, ladies and gentlemen, yes, owned by Eskom. And when you do a verification against another software program, which is the WinDeed, and again, if you search for 16127, yes, CPB is correct. It is actually owned by Eskom. Only to discover that the earth numbers were incorrectly captured and incorrectly reflected on the system. So, where does it leave us? The importance, dear colleagues, is the importance of verifying cadastral information. And what we see is the domino effect of feeding from the one source into the next source, into the other source, and what it caused. And the lessons and recommendations there is, why it matters is to avoid boundary disputes. You could have, correlating the framed earth diagram with what is on the GIS platform. So you have to physically take the diagrams, plot it, and correlate it against what you have and you find on your software tools that you use. Also, verifying those diagrams against the noting sheets. In Cape Town, I know at least, they've stopped verifying or stopped updating the noting sheets. And then also check and verify your property extent. That the size of a property, if it's 1 hectare, but it actually reflects as 1 hectare. Then verifying of ownership. What we saw through those different 2 sources, the CPB and Riskcape and WinDeed, is that there could be differences in ownership depending on which database service provider you use. And it's also, again, understanding the effect that that will have. And when it comes to property transfers, especially in this case that took place in 1988, late 90s, beginning of 2000s, is where's that historical information? When you just speak to the landowner, he says, no, but my dad says, we agreed with that person that used to work at Eskom that that portion of land will be subdivided, or that portion will be consolidated, and there were agreements in place for that. When you say now produce the agreements, then no information is to be found. And also because the site was then regarded as generation, so you found trying to locate a title deed that's not sitting in a space within the Western Cape. Makes it also difficult. So it's to check for all endorsements against a property via a deed, to also check that all information is also stored in a central database. Then thirdly, what we found is that the first thing when we start the discussions and negotiations with the landowner is they appoint an attorney. And immediately you're starting dealing with attorney, with his paralegal, with this support and this other person. And then you find yourselves that you're also reliable and dependable on your legal advisor sitting somewhere else in the country. When it comes to property, you want to see something face-to-face. When it's speaking to face-to-face, like the previous speaker says, but also when it comes to dealings with landowners, you also want to have it face-to-face. And it's not always possible to have a legal advisor flying down to Cape Town and to go and have negotiations and dealings and discussions around property matters and transfer matters. And to have that kind of support almost on a 24/7 basis, that's important when it comes to land transfers. And it's the active participation of your legal expertise throughout this process. It is looking at the legal complexities. Besides just signing an agreement and transferring land, there's always other legal requirements that's also required as part of this process that makes up this transfer. And that can also slow down your transaction process. And then lastly, I think enough couldn't be said about stakeholder engagement, but more importantly, what I want to stress here is relationships. The seller has agreed to sell the land to Eskom, but he's not going away. He's our neighbor. And in everything, to have an amicable relationship with your seller that you're buying from or the surrounding neighbors. And what you also find, because of the magnitude of this project, is that the municipality and a lot of role players, they were in good support of this project. And wherever you went, whoever you spoke to in that local community, everyone was hyped up, excited about this project and what it was doing for this town of Worcester. And that is important. More importantly is the lasting legacy that we leave, especially also not avoiding that this leaves a sour taste in the mouth. So what we see today is obviously a completely beautiful, different picture to what we saw 2-3 years ago. And I want to conclude by saying that the land acquisition process requires thorough attention to detail, legal expertise, and proactive communication. Verifying ownership and cadastral data is critical in avoiding disputes. And always verify and double-check and check and double-check again every detail of ownership and cadastral information to safeguard against legal issues and financial losses in the land acquisition process. And then Eskom has got this beautiful in-house duty of care. And when things go wrong, when you have problems and issues, it's important to take ownership, to clarify your role. And I think that's also a golden thread that came out through all the presentations throughout this morning already, is to problem solve, to don't blame others, and to learn from those mistakes. Thank you.
Thank you very much, Owen. You know, part of the engineering work says you must talk about competence. You do the work that you are competent in. And in legal terms, I am not competent at all. I don't think, even the jargon, the prima facie, I don't know what those things mean. So I think best I stay away from those. Let me call up Namhla. Okay, that's Namhla's bio. And I'll try and skim through it. Okay. Namhla is a dedicated and highly qualified environmental management specialist with extensive experience in environmental legislation, compliance, and project management. She currently serves as the environmental manager at Eskom Distribution Western Cape, where she leads a team ensuring the successful delivery of Eskom project. In addition to her current role, Namhla has acted as a land development manager and is presently managing land and rights for ESCOM. She holds a BA in Geography and Environmental Science, a BA Honours in Development Studies, and an advanced diploma in Project Management. Her qualifications are completed by specialized training in ISO 14001. With expertise in applying the National Environmental Management Act, NEMA, Environmental Impact Assessment, EIA, and other critical environmental legislations, Namhla has successfully managed environmental evaluations, facilitated training for staff and contractors, and represented ESCOM at Intergovernmental Coordination Committee. Ladies and gentlemen, Namhla Tondi.
Good afternoon, ladies and gentlemen. Thank you very much, Program Director. I'm hoping that I will really not be long. I can hear the second pot. They are busy, so before we fall asleep, I'm glad that I came in before lunchtime so that they are not fully asleep. Thank you very much for the opportunity. I'm really honored to be here to share the lessons learned from the environmental perspective. I'm part of the group of people that really worked on this project back then when we started. Monde's brief was that I should really just share the stories and the challenges and the experience that we've gained over the years. When we started back, we knew nothing about battery storage. We had to go and really read up on the environmental legislation to try and understand what are the requirements, what would be the permitting processes, and what would be the risk and the impacts. And we needed to provide answers and consult quite extensively with industries and the department to get to where we are today. And really, I had to actually go back into memory, Monde, when you said, just tell us, the steps that you took to get to the permits that you eventually obtained. I really will not be long in my background information. We know about the two phases of the project, which the capacity of the 1,440 for phase 1 and phase 2, which is the projects where we already then have the environmental permits in place. Just as a roadmap, we started back in 2017, 2018, which was the research phase, going out to the sites, trying to understand, okay, what did I do? It's too sensitive, no? So back in 2017, we were looking at various sites in the Western Cape alone. We had over 24 sites. And obviously, I think Monde has already touched on the criteria that was looked at to make a determination of why those sites would be the best sites. And from our side, we were trying to then understand what would be the risk pertaining to the technology that was brought into those environments and come up with the mitigation measures, and in particular then actually clarify the scope in order to get to a permitting process that would be the most relevant. And then in defining that scope, we did consultations with the Department of Environmental Affairs and Development Planning. I don't know, am I touching this thing so much that it's tripping? What must I do? And we had few consultation because the legislation was really silent on the technology. It was something new. Not a lot of people knew much about it in order to be able to say what is actually sitting in the legislation and what would be the permit in terms of the sensitivity and the impacts. So in clarifying that scope, I must say we really struggled to really formulate what that was, but we got to a point where we could at least then appoint the consultants, and that happened in 2019. That EAPS stands for the Environmental Assessment Practitioners that were appointed. As per the NEMA legislation, you need to appoint independent consultant to undertake the studies for you. And then we were eventually left with a number of sites then that we could undertake those studies for. I think in the following map, I'll show what those are, and they were already shared already. The first EA, which is the environmental authorization, came in 2020, and we were finally able to be in a position to say now we can actually start with construction, and the bidding process could then basically start, informed by the fact that we now knew we could undertake these studies, and we developed the specifications then in alignment with the funders, which was the World Bank in 2021, which also then rolled out into the bidding phase. The evaluation process was quite an extensive one around the period of COVID. We were back and forth traveling to get to the ESCOM offices to ensure that we could, do the verification of the documentation and be able to pass the bidders in 2022. And then I think around that time, the process of construction started, particularly on the HEC site, right? Here is really just showing the sites that are, the blue is showing all the phase 1 sites. HEX is at the bottom there. We've got the biggest one, Scarplay, sitting within the SAIEE wind farm in the west coast. And then there's 2 others that are sitting in the Western Cape, which is Grafwater and Balesiaville. We've got Melkout in the Eastern Cape forming part of phase 1, not yet in construction. And then the 2 that are almost at operational stage are Elandskop and Pongola that was shared. And then the phase 2 sites are the sort of brownish sites, Ashton and Witzenberg in the Western Cape, and then Kiwano and Kupram in the Northern Cape. So in trying to really determine what were the applicable legislative requirements, we interrogated NEMA, and I think what we know now is very different to what we knew then. And as part of a approach to ensure that, we were mitigating against the risks that we really didn't know much of, we took the approach of ensuring that we were able to have the permits and consult, and the technology options that were given to us at the time led us to understand that listing notice 1 in terms of the NEMA basic assessment process for the handling and storage of a dangerous good was potentially a listed activity that would be triggered in order for us to have a permit for that. And coupled with that was obviously the associated activities for clearing of vegetation, where you needed a site that was bigger than what ESCOM already owned land for, and therefore we triggered, for instance, the 300 square meters of indigenous vegetation, and for other sites such as the Scarplay site, we needed much bigger land, and we triggered those activities, or for instance, construction of roads in that particular site. When we put up the basic assessment process, we, as is norm with part of the environmental process, you need to provide the technology options, and you need to specify what is your preferred technology. In this particular case, we went the route of not specifying what that technology would be. As part and parcel of the requirements, we could not indicate. And so we put out these alternatives being the options that the solution that needed to come back from the bidders would be part and parcel of that. So hence the approach to say, let's put out for activity listing 1, activity 14, which was the handling and storage of a dangerous good, should that be the technology that then comes back. I think these are just photos of HEX. I think there's many that's already been shared. So in terms of the lessons learned, for us, I think the biggest challenge was in really pinning down the scope. At the time, really, there was very little information when we started back in 2017, 2018, to be able to say what exactly is the scope of this project. What technology are you going for? Part of the consultation that we did with the department, the question posed to us over and over was, what's the technology option that you're going for, ESCOM? And we really didn't know at the time, and we could not specify that we would be going with lithium or whatever technology. So that really made it difficult for us to actually be able to initiate the process. I think if you upfront know what is your preferred alternative, you are really able to drill down into what are the risks for that environment. I think that was a question the gentleman asked. What are the risks and how will you mitigate for that particular site? And you would definitely move much more different to the approach that we had taken. And obviously there were particular constraints in our environment. And that obviously leads to the decision process that the department then took, where when we were granted with the decision in 2020, we did not have the approvals for the layouts, which is a critical component of your environmental assessment, because you need to be able to show in that particular environment where your sensitive areas, you map those out. You obviously look at the mitigation then against how to ensure that you would limit your environmental impact in that particular space, and you obviously then translate that information into your environmental management plan. So the layout and the EMP itself were not approved as part of the environmental process, which meant that when we then had the bid approved, that supplier would need to indicate what is the technology solution, what are the risks associated with it, what's the mitigation that they are proposing for that particular environment. We need to take that document back into the public for public participation. So it ate into timelines for when you're actually getting ready for construction. So your approach may be different depending, obviously, on the constraints that you were working with, but those were the parameters that we were working with at the time. And this design issues also obviously speaks to this issue that I'm talking about, of the layouts that were not approved, how much road space do we need, the considerations for the 3-tier fencing, which ate up into a lot of the space that we had, because the particular sites that we eventually went with had their own limitations due to time constraints. We were working with sites that ESCOM already owned. And I think Owen obviously has just shared some of those challenges, but with that came its own challenges of, is the space adequate that we can work with, because what we were then approved for meant that the bidder must come in and fit their solution into the provided space that we had received a permit for. So those were some of the challenges that we were dealing with. So yeah, and then the site selection challenges, I think that was already touched on as well. I will not speak on the land issues because Owen has already touched on that. So translating to when we were in the EIA process to eventually where the permit was in place, after the bids were in place, we needed to then have them finalized to say, now this is the actual technology that is proposed here. What are the risks associated with it, which we found to be minimal. So we knew very different information at the point when we were finalizing the bids to when we actually started the studies. And then that solution needed to now translate to what are those risks, what would be the impact, and how would you mitigate against that. Finalize that information, finalize the layouts, take it out again to the public participation. So there was timelines that we needed to cater for when the bidders eventually came on board to be able to say, we are actually ready. So in the timeline, we're ready for construction in the sense that we've got the permit, we can go ahead. However, it was not a complete permit because we needed to go back into the public, do those consultations. So part and parcel of the requirements to ensure that the public is aware of the document is the public participation process, which specifically addresses the risks on the environmental factors. And then when that was approved, we were eventually able to be in a position to start construction, bearing in mind all of those factors. So in a nutshell, that is the process that we undertook. And during construction, what was also interesting was some of the sites, we only triggered listing notice 14, the handling and of a dangerous good. So the technology that eventually was then provided for those sites did not trigger because it was not a flow battery, it was a low risk solution. And the department then advised us that it is up to us to decide whether we will keep those permits, meaning you then have to ensure compliance to every condition in that EA as well as the EMP, or we could nullify them and we took the approach of deciding to nullify them. Obviously, that means all of the work that has then gone in, you take it as lessons learned, but our approach was obviously due to the fact that we could not specify the technologies at the time, so we had taken that approach. But if you know your technology up front and you can be specific in terms of what you prefer, I think you are able to know your risks much more clearly, and that helps you to take a sort of a different course in your approach. So the 3 sites in particular in the Western Cape, as a FONE, so HEX, by the time we were given this information to nullify, had already progressed, so that one we kind of just allowed the permitting process to, inform the construction process and the compliance. And the Graaff-Water and Paleisievel, we have nullified. However, we, as part of duty of care, we are still, monitoring and ensuring that we are compliant. And then the site, the biggest one we have in the Western Cape, which is Skarpvlei, we are, that permit is valid still, that EA, because it triggered other listed activities aside from listing notice 14, although that one itself is not a trigger. But for instance, we've got construction of a road, the clearance of vegetation on your greenfields space, and that's the approach.
In the area, and then they would recommend what measures we need to put in place. Yeah. So you would notice that 30 fence we would normally put at the national key point. But this site is important for us from a network management perspective, so that's why we went there too.
With the same reason why batteries get stolen. That's for another hand. Yes, sir.
Yeah, it's a question maybe not directed to you, but on one of the slides I could see there was a water tank for firefighting. So I assume if there is a major fire, they're going to use that water to quench the fire. And that liquid will be contaminated with some type of chemicals from the fire. How will that affect your EIA?
The placement of the battery, let me call it that, is actually within a banded area in order to also contain. So those are part and parcel of the risks that we have taken into consideration. Yes, no, yeah. So it wouldn't be something that we would discharge. So as like with our oil dams, etc. So those were considerations that we have placed in place. Thanks.
Follow-up, okay. Just to follow up on that one, I'm just interested
Water
to
and
know
lithium.
why. Why is there water? Yeah.
Why is that?
Water.
I think it's many levels, no? First the chemical
yeah,
reaction to block the battery.
So when you have a fire, when you have a thermal event, when you do the design, you do your best to make sure that all the passive and active protections are in place from a design perspective, contain it. But there's only so much you can do from it. Otherwise, it becomes too expensive. So what we looked at from a design perspective is the primary containment if there's an incident, and then also the bund walls are the secondary containment for the electrolyte or oil or whatever. But when there's a fire, it's most likely that the fire brigade would disregard all of those things. They will just spray the entire site. So you won't be able to really manage it. So you do the best that you can from a design perspective. They also need to take that into consideration when you do the EIA. So, yeah.
Thank you.
Thank you very much. Thank you very much. Thank you. Our next speaker, ladies and gentlemen, Engineer Nobisa Njoli. She's a seasoned professional with over 7 years of experience in network optimization and network control. She specializes in great impact studies and renewable energy integration. She's committed to enhancing network efficiency and reliability, and recently led the successful network integration of the first hex battery energy storage system, BESS, into the grid. Ladies and gentlemen, please welcome Nobisa Njoli.
Okay. It's written Nobisa final, right?
Did you say that?
Is it this one?
I tried to find now. Is it not here?
It's okay. Let's check.
I saved.
While they do that, can I ask all the presenters after this last session, after the last session, just for lunch, to please stay behind. I think they want to take a picture of all the presenters together. So.
Good afternoon, colleagues. My name is Nobisa Njoli. I'll be just presenting in terms of the process we took to actually get to a place whereby we are able to integrate and control the BESS plant into the system. When we approached, I think the BESS was already in construction, but sometimes because we are in operation, we sort of tend to lose focus of what is happening. So we approach in terms of will the BESS plant be ready? And what I'm trying to highlight is we had really a short notice, and there was a request to ask for volunteers in terms of leading the signal listing. We did not have a choice in the Western Cape because we understood we're the first one. And so there were hence then we volunteered, myself, Supokazi, and David Busak. Then we volunteered to sort of try, and this, I didn't ask where to control. All right, I'm here, thank you. So this is basically what I'll be covering in terms of the process we took, and then at the end I'll just share the key lessons in summary, and then the dispatching now that we are currently doing, and the investigation that is going into effectively dispatching the BESS. And this is the overview in terms of the monitoring and control. So in the Western Cape, we have had a fair share amount of renewable integration in our network, but what was different with this one was that the BESS plant now belonged to distribution, and also it was a dispatchable plant because we used to running solar and wind where it's not dispatchable. So we had to find now and strategize in terms of what is the best way to monitor this plant and also to control it. And then through the engagement from the contractor and understanding the signals, especially the battery health itself, the monitoring that is required, we saw there's quite an extensive alarms and monitoring and signals that need to be there. So we had to decide an area of boundary in terms of the control center, because the control center is also looking after the whole of the Western Cape and part of the Northern Cape network. So it would have been a lot of work for the control officers to monitor all the signals that are coming through, especially from the battery health. So if you see there's a site. There's no point. I'll just use my finger. There's a monitoring system on site, and then we have the off-site remote monitoring system, and then this is our regional control center. Also, we're interfacing with national control. This plant is a category C, where national control needs to have visibility of it. And what was critical there, also this plant was offering ancillary services. So we had to now understand what signals are required by by national control
control and also on our side. So the first point then we took was to identify the boundary of operation. It is not clear, but if you see from the bottom, we then decided because of those signals, after we went through the controller in terms of what will be coming in and what will be monitored, there was a list of signals that they provided. And then we saw that these ones, they would need to go to the monitoring center, and then we monitor mostly the ones that are impacting the grid into the control center. So we had that boundary in terms of what signals are needed into the control center. This is how we're currently monitoring now. At the bottom, at the HMAs, at the monitoring site at Megawatt, they are monitoring it. And then all the way from the transformer up, all the MV side is monitored at our control center. But we are getting critical alarms that would interfere with the plant from the BESS plant itself. And there is communication between the two control center and the monitoring center in order to ensure that the plant is managed effectively. And this is the roadmap we took in terms of actually getting the plant to where it integrates with the grid effectively. So there was a process of identifying the signal lists, and then we went through the dry run test, and then we went through the SCADA functionality test. And the dry run test, the requirements, we used the BESS grid code standard, so everything that is outlined there. But over and above the requirement for the dry run test, for the signal listing, we had to understand now this is our plant, we are controlling it, and what is different, we will also be charging and discharging into the grid. What additional signals do we require over and above the grid code? So how we went about it, we formulated then a working group with all the experts. Luckily, ESCOM has many OUs, so we integrated many OUs, system operator, where we put in the heads of the engineers together to see from this plant what do we want to see, how do we want to monitor, what controls do we need in the control room over and above the grid code requirements. We came up to revision 23 with the back and forth. With the back and forth, realizing, okay, we need this, and then we went into the commissioning. The signals were commissioned, but then after we had the display, we realized, all right, there is some signals that we missed. Also, we consulted with our generation counterparts as well in the peaking that are already owning the plant to see what is their view in terms of when you own the plant, what do you need to do, what sort of monitoring do you need. And then that's where we also saw the requirement for historian, where we must have some signals that are going to historian because we want to monitor the plant performance over a period, but we can't have all that data coming to our SCADA system with interfering with the controller monitoring. And the part that was created, the ancillary services, it was the first for distribution to be interfacing the ancillary services. We had to engage system operator a number of meetings to understand what is the requirement for ancillary services. We went through the existing plants, even though they are coal-powered plant, but to just get an idea what actually gets the plant to be certified for ancillary services, what are the signals that are required, and then the discharging, because usually, even though we have experience with the renewables, solar and wind, they are not dispatchable, they come in. So we had to understand now we're dispatching this plant, and also how can we optimize the dispatching. So all that went into that working group, where we discuss all those requirements with the back and forth, and then we had to confirm from the contractor that was offering the services what are the available signals and compare them with the existing plants as well that you have, and to look now, but for the dispatchable plant, what additional listing do we want? And then after those signals were tested, the SCADA team, they actually said after they've identified, there weren't that much issues in terms of testing those plants. And then we then went into the dry run test. We had a lot of back and forth. I think I'll share as well at the end with the lessons learned. In terms of the dry run test, we had a lot of issues with the PPC, the communication. I think my colleague mentioned, even after the plant has passed, we had a lot of issues with the communication to the plant. We'd also delayed the dry run testing, so we had to stop. I think what we picked up as well was the reconfiguration of the PPC, where there was also no interlocking with the mode. So if we're testing the voltage mode, but you'll see the other response from another, so we had to stop, and then the contractor goes back and actually apply the settings correctly. But in the end, then this is what was tested, and the plant actually passed. And then we went to the SCADA functionality test, and we had to look at the dashboard. What do we want to see when we're controlling this plant? What signals do we want to be visible for the controllers, because we know that there are many signals coming in, but what are the important signals for the controllers to see as well? What sort of interface do we want the controller to speak to this one? This was actually a success. It was passed first time. I think the lot of work that went to do the dry run test made this one, and then we submitted all those results now to our retake test for the final compliance test, which was then done by our retake colleagues, and the plant actually passed. I'm just taking a screenshot of the main test that the plant was required to pass. In terms of the key lessons, what we learned from what I've just summarized: training for networks engineers, for controllers, 20 megawatts. We're not getting the 20 megawatts. I got a call from system operators say, what are you guys doing? Is this not a 20 megawatt plant? Because the output was very inconsistent, but that's when we picked up now the issues with the under voltages on some of the battery cells, and then we handed it back to the contractor to actually test, where they picked up, Thomas has mentioned that they picked up a lot of communication issues, and then they handed it back. And also I've mentioned that the PPC and the issues. The main thing, I think, what helped to sort of ease the process, we had several sessions with the contractor to go through the grid code standards, South African standards, to see that is there a common understanding in terms of what the plant is expected to respond, and what are the tests that the plant is required if they are able. So we had several sessions where they were taken through. We tried it online and we saw it's not working well. Then we organized a face-to-face session where we went through that, and then we went through all the standards as well, because we have a guideline that we use to sort of test the plant. So we took the contractor through that and the steps that will be taken in order for the plant to pass. It was very effective because the contractor could then confirm if your plant is able to actually give the output that we are requiring. And this is the graph. I think when we investigated then in terms of the output, the inconsistent output we're getting, as you can see the straight line, we can see that some of the banks were not responding to the signal that was sent from the PPC. But that has since been resolved. I will show a graph, but before I go to that one, we are currently dispatching it now. We can say it is a success. We're dispatching it now we're dispatching for system peak at the moment, the use case. It does have the use case for peak shaving, but we only have constraint in the network around summer, and it only came into line after the agricultural season has passed. So we're dispatching it. We have the one cycle in the evening where we're charging it during off-peak. And it actually helps because our control center is the one that actually has curtailment from renewable power. But it does say that we don't have enough at the moment, but we can see the benefit when we have enough battery storage, where at that time we are charging, that's when we'll be avoiding the curtailment. And then we sort of discharge it with the system peak in the morning. We're doing the winter peak now. So we're going to go now into the off-season peak. There were also calculations that were done to show there was a saving from the distribution perspective at the moment. In terms of how we've saved when we're charging it during the off-peak and then dispatching back peak season. So distribution has actually made some savings, but they're still doing, I think it would be premature to say how much has been saved because they're still doing, and then they're making a comparison as well with the ancillary services where we're seeing the more benefit will be more for ancillary services. But we're still waiting for the plan to pass so that we can actually now see and realize those benefits from the plant. But there's a team that is looking into that, our distribution energy trading. They're starting to look into that option. And this was the outcome after we've resolved, but you see there are still minor issues we need to look into, showing the the night charging we're doing, and then the dispatching, the 2 cycles we're dispatching in the day. Thank you, colleagues.
Thank you very much, Engineer Njoli. I must say, part of my work is to look at disturbances on the network. Where we have PMUs installed, I can see disturbances, and they come as oscillations, where they are negatively damped or positively damped. You can see all of that. But I must say, since we've installed PMUs at HEX, the battery energy storage plots are the most boring plots to look at.
Yes.
It's either on or off.
Yes.
Or there's nothing special about it. I don't know if there's any questions for Njoli. Okay, can I take 3 at best? Okay, I'm going to start here, and I'll come this way. Yes, sir.
Okay, thanks for the beautiful presentation. I just want to know, what is the design operating range of the battery SOC? Because that is very important, right? Because you're coming from the point of renewable energy integration to the grid, right? Now, if that is not included in the design, you know that it will affect the performance of the battery and also the lifespan. So I just want to know, what is the design operating range of the battery SOC?
In terms of how much its capacity it can.
Yes, okay. In terms, when you do design, most times I'm coming from academia, okay? So when you do design, most times you can design, let's say between 20% minimum, okay, SOC, and let's say 80% SOC. So I want to know, in terms of your design for this specific work, what was the range?
So it's remember we rely
So I'm just interested to know when it's being dispatched, what mode does it operate on?
Well, we actually connect in voltage mode. Do you wanna? So she's part. No, yeah, it's part of the working group.
Okay.
So for testing, we test on remote.
Mm.
Then these studies will determine the optimal mode, which is voltage.
Voltage.
But if we cannot use voltage control for whatever reason, then we can move to the
To the Q control. But all our plants at the moment, we connected them on voltage mode.
Okay. Let's start there.
Thank you for the presentation. My question is on the compliance tests. Do you also have to do them after you do your meditation? There is maybe you now have installed a new BESS bay
It's the whole plant that we test, yes, yes.
Okay, you can have the final one.
Okay, as a result of this jumping on, can I be honored to ask two please?
No, you allowed one. I'll have to allow you one.
Okay, all right. We know what happens with transformers and generators when they are feeding a fault. Now, I've just been scratching my head. Are they not going to be, now that you've integrated them, it means you've put a generator now closer to where the fault will be. I don't know if you know what I mean. You've introduced a new generator now.
Yes, in terms of fault level.
When we are closer to generation, the fault level the main equipment was so you will see these traditionally these are the calculation times. You've got 10 seconds, 10 minutes, 10 minutes. But then because batteries are got this capability to switch on very, very fast, so those activation times actually rise as current focus and batteries that there are now certain times where the system experiences high frequency explosions as well as sometimes low frequency explosions. High frequency will not really but now you know the technology that we coming from the interplay and the low voltage conditioning and you start to experience high frequency explosions. Now with the battery, I'm going to see the this slide. You can use it as a generator, so you can use it as a way to conventional now this is the transfer services pump and if you look at this activation time, here we are now in the minus 27 minutes, it's 10 minutes, it's a part of the minute. And I think most of the movement of the first two are actually so looks like the process is still underway. Talks between the establishment. So the challenges with this topic well, in this session, we are understanding that ESCOM and all of us need to establish implementation. I think at least 60 where there are a lot of clarification. What you do in 10 minutes, but in 10 minutes, there, some problems. So the lessons implement. There are questions for auxiliary service provision should be addressed in the stages of the project. And I think we did try to do this, hence we received those requirements in the planning report as well. So auxiliary services certification should be coordinated with the test to ensure that the enforcement is right. And so basically when you do the test, you need to coordinate with the certification process. I think that was all. Thank you.
Thank you very much, Engineer Soli. On behalf of Engineer Joseph, well done for doing shit like that. Very well done, indeed. I don't suppose you want 80 questions or we can give it a go. Okay, let's give it a shot. I'll take 2 questions. 1, 2. Please. 2. Okay. I'll start here.
There's a huge benefit of standardization from both the operating point of view and maintenance and spares. How different are the different BESS systems? And if you have a BESS system that you want, and through so you want the whole bank sheet of services as opposed to just one service, what's the difference in price and how different is it? Because where I'm going to is, can't we have a standard thing where you just plug and play and copy and paste? Sorry, there's a huge benefit of standardization. So if you do the same thing over and over again. The question is, if you have a BESS system where you only want ancillary services, is that very different from a BESS where you want just frequency control and another one where you want voltage? Is it not better to have one suite and they all do everything?
Yeah. So I think earlier I mentioned statement and arrangements where you utilize your benefits for whatever you put into it. So I would say instead of saying here's ones, appointed ones for the services, it's better to actually say ancillary services and maybe change something else. Then you can see whatever you need at that point in time on the day ahead contracting, then you know you will always use whatever the system needs. But you still want to have the flexibility so that you can to have some.
Right, thanks. So you can cut and paste and put the same facilities for our storage all over the country at all MTSs.
Yeah, correct. In terms of duration, 4 hours seems to be the cut and paste. In terms of use cases, ancillary services and energy support, they seem to be not the cut and paste. Question?
I'll be very brief. Is this plant under the control of the system operator on the technical level, right? In a market environment, will it be put into the day-ahead market for reserves through the CPA, is it a purchasing entity? That would be my first question. And secondly, this is not a technical question, more for technical economics. At what rates does the battery charge at your normal WEPS rates, time of use? Is that how you guys are arbitraging it? And secondly, how is it reimbursed by the system operator for the ancillary services it provides? Is that sort of costing it? Thank you.
For the first question, in terms of who's under system operator, it's under distribution in the regional competition at the moment. Sorry, what was the follow-up question? How is it reimbursed? How is it?
Will it be in the market? Will it be bid in by the CPA?
Not the CPA. My understanding is still a competition and it will fall under the duty of the
The next session is pretty short, so just bear with us, we're almost there. Thank you very much.
together with a number of field experts here, right from land and rights. So I'm not going to talk, I'm an electrical engineer, but I'm not going to be referring to electrical engineering work because I was leading a team. So I'll be talking across the board from all experts, and they are all experts in their respective fields. And with that, I would like to give my team a round of applause and congratulate them for the job well done. Thank you. And with that, once the project was completed, we decided to have this initially as a ESCOM. First of all, the purpose of this presentation is to provide the business with guidelines which can be used as tools in considering future battery energy storage projects, because we have started, this is a first. So we have to set a benchmark. If we did well in some other areas, so be it. Where we struggled, we have to learn and pull all stops and go back to the drawing board, which we kept on doing. And then to provide actual experiences related to energy storage projects within ESCOM. And as ESCOM is the benchmark of the rest of the utilities in Africa as white and the like, that works well for us. We keep on setting the pace. And then to ensure that the lessons that we have learned, they are captured. We have seen since morning a lot of presentations which I'm well aware we have worked together, captured, recorded, and distributed, and trainings come after that. After distributed, there is a word training that must come there, so that all organizations or institutions that are dealing with BESS can have a benchmark and say, this is where we start. And if we are, as a country, because there are various technologies that are being asked and the like. And then the balanced approach that I've used is the introspection, which says what went wrong during the project and the suggestions to avoid similar pitfalls. But it does not mean that everything went well. No. And it does not mean that everyone was laughing and relaxed like how we are working. No. And it does not mean that engineers only were involved. That's why I put here is how engineers, land and rights, environmentalists, project managers, stakeholders, the local communities, they can capitalize on such projects and teach us, because everyone who's around here is an expert in their respective field. For example, Namsha was presenting. Nwabisa was also here. She's an expert. Owen is an expert in this. Everyone who's here is an expert. So we all know clarity, determine the problems that occurred, and ensure that we don't make the same mistakes over and over again. We are a learning institution and we are a learning country, and then we're moving forward. Now, in terms of the lessons learned, I put a summary here from the engineering perspective, because the whole team, everyone here was called engineering. So from a procurement perspective, we were on time. Why did this happen? Because I, as the lead engineer, I allowed engineers specifically, because when we went to land and rights, we had already done a lot of engineering with people like Thomas on specifications, well ahead of the project. So we spent a lot of time on planning so that we don't fail, because 20% of the time it will be implementation, but the whole planning, what are the effects? All these questions that we're asking, we try to answer all of them at the planning phase. So the timed delivery of the targets were set by the team, and then from a risk management perspective, we fairly covered it. Some came in late, and it could have meant that some experiences gained in national base were there. There were some duplicate tasks. We had to cut them and ensure that we clean up all these items. We had a lot of stakeholder consultation, recommended. We kept the same tactic. We will not be in an area where we go to a certain area and then we try and dominate it, because we are very good electrical engineers. We can do all these calculations. That's not what people want to hear. People want to understand, what is it that is going to happen when you bring this BESS? We cannot keep on explaining to you how this frequency works or how this electromagnetic wave works. It's not going to help. We have to go lower and explain it, make it simple. And that's what we did. And in so doing, we ensured that we use our internal ESCOM expertise as much as possible. So it's very little consultancy in terms of external consultants, because we try to build a team that is strong and respect everyone and give them the necessary skills. And then we had a very good integration team, which was fairly well balanced. It also had consultation with external stakeholders. No consultation on, so we have a lot of, we had a funnel, and because it's in the public domain that ESCOM has got financial challenges. We've been going through that, but however, we had to upskill ourselves. For example, when we started with people like Monde and Thomas, we had to write the equations on the board about how do we model and plan for BESS. What will it do? The power flows, both steady state, dynamic, transient, what happens? And then when you integrate all these items, what happens? How do you change the power flows? At the micro level and the macro level, and then development that, and then ensure that when we finish this project, we've achieved a number of things. First of all, if you look at the evolution of and the development of the skills that we have achieved, we didn't have BESS planning specialists, we didn't have BESS design engineers, we didn't have any integration engineers on BESS, we didn't have any environmentalists. For example, I'll give an example. I'm not going to give an engineering example because everyone has been talking about engineers. I'll give you a good flavor, and I'll give it to the woman there, and Namhla. I sat down for several hours with their team while we're busy looking at the batteries, which is what Thomas was presenting. I said, Namhla and your team, and Wazir, you will be putting chemicals. We have never put chemicals in substations. Don't you have a certain legislation that says, if you've got so many chemicals that spill, I've heard about this, all these chemicals that spill, how does it apply to our substations? What will it do if it spills over? They scrambled, it sleepless nights. They came back, there's a certain clause, but I know that it's got something like, I think it's 5,000 cubic meters or 6,000 cubic meters. That is the essence of developing from almost like being a graduate EIT or being a professional where you understand something, where you guide and you direct your peer review. And because ESCOM is a large university, several universities, we've got the clusters. So people like in the MNO space, we had to question ourselves and say, if these chemicals spill, where will they go? We know what happens when transformer spills at a substation is our bread and butter. But we don't know about chemicals of this size. They brought us, they guided us, they gave us guidelines. On the planning side, we don't understand the relationship between synchronous condensers, the BESS, the wind and the like. People like Monde and the rest of the team planners, they led on that stage together with myself. We had to recraft the equations and say, this is what we do. But the good part about this is that everyone was working independently. And that is one aspect that made our teamwork move. So it wasn't a question of, I as a power systems analyst, therefore, these land and rights people just go and do whatever. No, no, no. It was paralleling. While we are busy with the power systems planning, Namhla, Nwabisa, others, they are busy, they're in the field, and we've given them their tasks. So to ensure that at the end of the day, we meet the targets. Now, why am I presenting this slide about the evolution of and the development of skills? This was a World Bank funded project. So there are a number of questions that were asked. And the intention of the BESS project was to ensure that, as a pilot, it ensures that when it's done, we have a good proof of concept that works. But we also have our own people and us who know and understand what is it that was done from the fundamental. We don't hear about it, we don't read it, we do it. And that's what we did. So a lot of people that we started with, they were not at the graduate level, no. They were the experienced as professionals in their respective field because of the time constraints when we started around 2018, October, yes. And then we brought in some consultants around early 2019. Then they showed us a number of things about planning here and there. And then after that, we said, no, we are going to do it ourselves. Because what they were doing, it looked complicated. But when you look at it as an engineer and you start doing your own calculations, you've discovered that, no. This is just a simple formula. I can work on it. It's because I followed the fundamentals. What is it that will change? We turned that. And then we started turning out the reports. Then we're evolving. And then we started getting comments from other industry experts. And then the World Bank started questioning us. We appreciate that. And then we had, when we're busy with this, we're not doing this in isolation, because we have to respect the processes of running a project, not only ESCOM, but a system that works when you start from concept right up to from birth to the graveyard, as Thomas explained it earlier on. So I'm not going to go back and touch on all this, which is the concepts, what is the issue, clearly defined, where we didn't have, for example, even on the legal side, I've left out, I'm not leaving the other fields because of time, where they clearly articulate to us, what does it mean when you talk about this technology, and then SWOT analysis, the cost of the budget, and then the designs. Thomas delved into that, Monde delved into the system operator as CIJU. So all those things that were presented there about the trading, Monde, CIJU, myself, Thomas, and everyone else, we had to craft that from scratch. It wasn't there. We had to work on it. So that is part of, to say, but if you do it like this, before Nwabisa left here, she explained that the regional control centers, control center in Cape Town, is where this hex BESS is available, the hex is visible. But we have to ask ourselves, going ahead, we're talking about the energy transition, we'll have the distribution system operator. How are we going to have all these small BESS all over visible? We have to have the distribution system operator, which is aligned with what our group executives and ESCOM distribution evolution is. So we'll have distribution system operators where all these BESSes will be available. But even if we have that, let's say we've got the highest people in the organization in the country. They want to understand how do these things work. We have to build a battery monitoring center in Megawatt Park, which is what one of the supplier Harrisung was talking about. We started that from scratch. It's working. And we never had one. So it's the first of its kind in the country, the first of its kind in Africa, and the first of its kind in ESCOM. And there are going to be many of them by then now. Because it's evolving now, we have to make it a point that it is adaptable. Because it's not only Harrisung when we went EPC. Even the EPC were challenges because we've never done this. So it's not only Harrisung. For those that are already in the public domain, it's Harrisung, it's Pingao. Am I right? Yeah. So if we have Pingao, and then we have another one, we have a fourth one. Should we continue having battery monitoring control centers for Pingao, this one and that one? The answer definitely is no. We just have to have an integrated approach where we ensure that we have almost a seamless integration for setup, which allows that. The execution, we've got the execution team which is here. They had to correct us based on working on Cyril Wind Farm and other projects that they've done. So those learnings ensured that we respect the environment, we respect the experience that we have, we execute with the discipline that we work with. But we made errors in so doing. We can say even in terms of certain places, we made errors because it was a first. A wild idea. So for me personally, and for my team too, there are a number of things that I learned, that I had to improve on. You cannot talk about a complicated project of this magnitude and say you are setting a stencil and the like, and I sign off documents without knowing how the site looks like. There are a number of reviews that we made for HEX. The first time when we went there, there were a little bit of mounds, there were a little bit of telecoms. We changed it, we came back. When they told us about I think it's 5,000 cubic meters. Is it 5,000? 500 cubic meters. Yeah, my memory still works. Thank you. At least you are listening. And yeah, so we have to listen and learn to react quickly and to be available. And on availability was during COVID when we were dealing with this project. So we had to ensure that whatever was being asked, we had to have answers. And these answers were not only being provided to the people that I was working with. They had to go to our distribution executive committee. They had to go to the ExCom board. They had to go to the other committees and finances. So being available and listening, you get very harsh criticism from the higher levels. You take that, absorb it. Availability, you are not available. For the evaluations, you spend a lot of time trying to go through documents because the World Bank way of evaluating is totally different from how we do things. So we had to be thorough and go through each and every page, open the pages, sit down. I had a question that was being asked about that. Now, that was to ensure that everyone who put their bids forward is considered fairly and they are corrected and they understand why is it that they didn't make it. And they were to reclassify and move back and forth. We did it. And so that is when things started happening. And then the detail, which is what I'm talking about now. So the specifications were to try, specifically on the BESS, on the battery, on fire and the like. At one point, Thomas had put a certain way that works with it. And one bidder came and said, you are excluding us because we come from one geographical position of the world. That was a shock for us because for us, we're used to doing this. There's no, look at it this way. That's an admission. We went back. That is part of the availability and review. So we went back, changed all this, and said, oh, we are learning. It's new. Because it's a new ground. We've never touched it. We didn't know that other people were busy with this, or this is what they could be possibly be doing. So we had to learn, review, criticize ourselves, and be honest to ourselves about how we're being criticized. And then while working on all this, we're looking at the end state. So we're not looking at the network now with all these 20 megawatts. That's why we heard about augmentation. And even if you looked at how those battery arrays look like, possibly into the future, if it comes back, Niranjan is there from our project execution. They might come back and say, no, in operations here, why don't you build a firewall? Because these chemicals, we have got new studies because we have to do all the meteorological studies to say if the wind changes this way. But we know that all meteorological studies came wrong last week. We all know. Harry Smith and Van Riemen's Pass was like Iceland. So if the wind direction changes, we might alter those designs as they are. So we must be open to that. That's flexibility. And if we were saying, yes, we are engineers, yes, it won't work. So you have to focus on the problem. And I spoke about parallel work. We have to work in parallel as a team. And while doing all this, there is a number of things that were happening. The first one, that people had to be on time. People had to work hard, and people had to be honest. If you didn't know about a certain spec, you had to be honest. That's consistency. So there is no way in which land and rights were forced to come up with 500 cubic meters, and then land and rights, the demarcation, they came up with something. No. Everyone was given the same red line, underlined. Same with planning. Same with with battery, everyone was given, so that we ensure that as a team, we are all focusing on a single program, on a single line of focus. And I think this slide was supposed to have been cleaned up and come like this, but don't worry. So on the issues of the scope management, with all these factors that I've mentioned, we ensured that can say, you have to run with us, Ajit. I am not expecting you to start telling me, you get your right team. But at the same time, it does not mean that if you make a small mistake, you have to be shifted. It's consistency again, because you're going to make errors. So the revolving door, you have to be consistent and keep the team there, work with them. It was tough working on this project. So it's clear outputs and align to the bigger picture. From a quality management perspective, which is key, which is what we've been battling with even right now, we will never clear that as long as we're working on projects. We have what we call a design review team, technical team. That team is where you heard about the specialists, whether it's telecoms, it's civils, and the like. So every time we went through all these stages, whether it's a specific, it's a planning, whatever, we will bring it to a design review technical team, of which I'm the chairperson of that. And also part of the specification steering committee of technologies, of which I also chair this, so that we ensure that whatever battery technology that battery behavior that Thomas is talking about, a telecom specialist would question how is the BMS and EMS going to communicate with the battery, because Thomas is not a specialist in telecoms, no, and Monet will question that and say, okay, if it does that, how is it going to affect the depth of discharge? So walk the basics. That's why I said 80% of the time we spent reviewing and working on what we could have done, what we're going to do. So when we started doing it, we had already covered a number of our own gaps. We knew that we'll never be 100% correct. To minimize too many meetings on inquiries and blame games. And when you are working on a project like this, one of the things that we discovered was that it is critical that you have a meeting about a particular topic. That's it. Solve it. Whether it's 30 minutes, solve it, move away. You can't just put so many long items, you move from one to the other until people lose their energy and they are not focused. So you would rather have short, stretch message, single message. You must be visible and approachable. You must be accountable. So if I give Owen an accountability, for example, about this, it motivates him because he's accountable. But if I give Owen the task, then I ask Monde to come and explain the task, a message will be lost in translation. So put the people that are doing the job on the coal face. Let them feel it and advise you, even if you are leading, because they are experts in their respective field. And listen and absorb criticism. Criticism is part of the game. If you are at the forefront, those that criticized, I usually laugh and say, people that always say that they can't be criticized, they are doing nothing. And they haven't started anything, so you are doing a run of the mill.
So, what all these things were happening, a lot of people were criticizing them. Because they are so listen, absorb criticism, because you are passing through well entrenched norms. Business up and up. It's an unusual business. So it's move out of the comfort zone. This was an uncomfortable project. Total uncomfortable. Because we thought we're done. And respect each team members' expertise. Whether this person is from HR, is from IR, or is from respect and move on. There is a reason as to why they are that team. My team was big solution. I listened to them. Because they're experts. I know their roles. And I know how they express themselves, which I don't have that expertise. And then focus on the project solution. And not the person. And we are very informed about these things. I'm not talking no, I'm talking to the project because it is the idea that we have. We argue about that. I don't argue about things. Just clear that. So, and then, but it does not mean that we just say think out of the box. You think out of the box. With that being said, let's set priorities. Then decisions that we take for our day, and that says how we
Apologies, I have corrected that. But from me, two things, honestly speaking. The quality of a good manager is a manager that develops and encourages the employees. But not only that, a manager that acknowledges the employees' hard work. And we started off by giving a round of applause to the team. I think that's well received and thank you for doing that. Very much well done on that one. Number two, I think we've seen from what you did, what you're going to do here, that to resolve complex problems, us that if I say, why can't we do it ourselves? Why do we need to outsource this thing? Because surely accept as a company that the biggest asset of any company is employees. You go further as a company. The knowledge is the base of everything. Ladies and gentlemen, before we switch on to our online team, I'm just going to take 2 questions quickly. Go to the Songo. One there.
Okay, thank you. Thank you, Mr. Song, for the presentation. In your introduction, you mentioned that we are transitioning to cleaner forms of energy. And one of the requirements there is to decommission our coal-fired power stations. But this will have a negative impact on the grid because we'll be losing a lot of grid inertia. So, therefore, having a negative impact on your grid stability, your frequency. So, I know one of the devices that we can use to mitigate that is to use synchronous condensers. But I would like to know if ESCOM has had a look into grid forming capabilities of BESS, because in that way it's able to at least inject synthetic inertia. So that's what I would like to know.
Thank you very much. I'll ask you to pass on the grid formulations. And then I'll talk more about the transition.
Yes. Thank you.
So, I think it's a very important question. On grid forming, currently research, when a fault happens, we want to generate the same amount of current to potential instance. Then when it comes, so we need to have a source for the current. Then that's where practical problems start to what do you need about actually manipulating on the controller side? Now, for it to actually provide during the fault to provide the support, that's when the
And have you considered that in microgrids or maybe island grids?
Yeah, so it's likely in microgrid the way that grid forming in the sense that actually when they ahead of the system to maintain voltage and that is fine. But when you talk about grid voltage in the sense of grid type and wanting to provide the synthetic
okay.
Jennifer wants to know what is the end-to-end
offered obstacles. You can go to ESCOM, SIR, and work consulting, PSA program. As the head of the technical project IT office, provides technical oversight on the procurement of renewables, battery energy storage systems, as well as gas to power and other technologies. Ladies and gentlemen, Crescent and so on. Crescent, you can go ahead. You guys one day keep the recording. We'll share the recording with you guys. Let's see if I can do that.
It's just this.
Okay, we can hear you. Yes. Yes, you can proceed.
The IPP office, as a brief overview, was established in 2010 through a memorandum of agreement between DBSA, DMRE, and National Treasury, and this helped to facilitate the establishment of the office. And the mandate of the office basically comes from DMRE in terms of assisting DMRE to procure energy from the private sector, and the office itself, although it's Crescent from the outside. Crescent? Yes. Can you hear me? Yes, I can hear you. Okay, we are struggling to hear you from our side. Can I ask you to do this?
Have a program for the day. And we're going to do a vote of thanks. Before you do a vote of thanks, I just wanted to say, I see you've lost a lot of people in the room, but I think you've gone through very well through the rest of the day in the program. Thank you for being part of this momentous event. It was an absolute pleasure and a pleasure to be part of this event today. Thank you very much for that honor. Yeah, at the end of September, we have 3 months to go before the end of the year. We have not achieved the resolutions. It's for 3 months to do it. It can still be done. So please hang in there, stay strong, work hard, and it can be done. Thank you very much. Thank you.
Now I'm standing up in my capacity as the chair of the, I almost said load research, power and energy section. So I was the chair of the load research for a long time. So, so firstly, I would like to apologize for the overrun that we have experienced. I think nonetheless the engagements were very, electrifying. Thanks to the MC for the many pots system. Thank you so much. We didn't want to have you, but the other guy didn't want to come. But you are here now. So, really, thanks to the presenters, Hyo-sang, the ESCOM presenters. Thank you so much for the content that you shared with us. It was very, very relevant. And also thanks to the host, the hosting team. The host, the team, the organizing team, Divaksha, the chair of the energy storage chapter, working with Bongo here tirelessly, and the other guys that are probably online right now. I think you guys, like I said, you are my favorite chapter right now. I do have many chapters that I look after from the SAIEE perspective. Thanks to the CGC team, Debza and Keith. Thanks for being the blessers for the food that we are eating here today. The PAS members, the Power and Energy section members, thanks for joining hands. The IPP office, though we couldn't hear everything, I hope that Divaksha, we will get a recording and we'll try and augment, like our friend there said, put it together with whatever we have from here, and then we can have that up on YouTube. And I just want to also just really pass my thanks to ESCOM. I see the boss is not here right now, for actually agreeing to come and share with us this information. We have, ESCOM has received a number of requests
Last but not least, thanks to you guys, the audience, for coming in, committing to come actually really showing up. I think this is very amazing that
So those are some of the challenges, not technical land issues, because all has already touched on that.
This thing killed me. That one, I should have told. The team's one, it kills us because it was gonna work if they can hear. Because Mina here it was nice, the audio was okay, but they couldn't hear. They couldn't hear, that's the problem. And I don't know the system.